Okay, so this is the general troubleshooting of inside Nexus switch. So how you will follow the troubleshooting steps? So whenever a customer open a case or ticket with us, at that time what will happen? That something is broken, something is not working. So at that time what you will do? You will check. So what you will check first? First of all, you will check the logs. So a customer बोलेगा कि okay, something is broken, something is not working. I don't know why my packets are dropping. I don't know why there is high CPU. I don't know why some interfaces are down. I don't know why module is down, module is not responding. And those things may be critical, means suppose if their module is down or if their interfaces are down means interfaces may have two capabilities. Interfaces may belong to uplink or it may belong to downlink. So if their uplink is down, that means the connection that is going towards northbound, that means something is very, very bad. If their downlink is, that is the southbound, then you have some time that you can, manage something, you can do something. But if uplink is down, at that time, it should be like severity 1. So what you will do, suppose some modules are down, what you will do? Or suppose some services are down, services maybe OSPF is not working properly, or EIGRP has something called SIA, stuck inactive, and those states. So what you will do, even OSPF is flapping. So first of all, as a troubleshooting engineer, what we have to do, we have to collect informations. So as many as information you will collect, that will help that particular ticket in two ways. First way, that we have lots of input. On the top of that, we can build our logic. Okay, this may be cause, this may be trigger, this may be cause, something like that. Second thing, while we are collecting lots of input, something like topology diagram or logs or triggers, something like that. When we are collecting those things, what will happen, suppose if I'm going somewhere and that case is assigned to some other engineer. So again, he will not ask the same question to the customer. So two ways it will help the ticket. So in my case also, suppose if I am providing solution, it will help me, otherwise others as well. If some other engineer is working on that, or in future if he will work on that. Now collect the log is the first thing. So whenever you are doing troubleshooting, the first step should be to identify the problem. If you identify the problem, this is something like 80% of work done. To identify the problem, you have some attributes. What are the attributes you have? So you need log, you need topology diagram, you need other things, other logs. If some interrelated things are there, suppose I have two switch, and due to this switch is not working properly, or maybe somewhere in the network one of the PC is sending lots of broadcast packet to the switch. Due to that, the CPU is high. So you have to understand, how could you understand? You have to collect the logs. The first step should be identify the problem. If you identify the problem correctly, that means you are very near to the solution. The second step is to prepare the plan for solution. So for a particular problem, you may have solution. So you may have some fix. Commonly it is known as hot fix. That means you may have something called temporary solution or workaround, or you are going to give some permanent solution. So you have fix with you, and third stage that you have to apply the fix. So this is your communication skill, and your experience will come into the picture. Means how you are going to convince the customer that this is the problem and this is the solution. If you use this solution, your issue will get resolved. So here your communication skill or your management skill will come into the picture when you are going to apply the solution in the customer environment. And again, the weightage of this is very high. So three things are very important: to identify the problem, to prepare the blueprint for the solution. So you may have temporary solution, you may have permanent solution. Again, this temporary solution and this permanent solution depends. If you are in a critical environment where customer, they don't have maintenance window, they can't reload or they can't change the module, at that time you have to give some temporary fix. Okay, so I'll come to this temporary fix. There are number of different temporary fix that we can offer to the customer according to their criticality of the network. And then you have the permanent fix that you have upgraded, you identify the bug and you have upgraded or downgraded the iOS, or you identify the module and then you have RMA the module, or you identify the layer 1 issue that, oh, cable is faulty, or you have some CRC error, or you have some runs or giants. So all these things are hardware related issues. You identify that, and after that you told them, okay, you have to change cable from your side, or you have to change the cable or optic path from the ISP side. So if you go through all the case, if you do all the research on the case history, you will find that if your switch or your router is connected with ISP, it's like 50-50%. 50% of time this is the issue with the ISP. 50% of time that will be the issue with your environment or your switch. So again, the identification of problem is very important. Then you have multiple ways to reach towards the solution. So this is the general troubleshooting step, that you have to identify the problem and the expectations. Okay, I'll go to the next slide.
There one question is there.
Yeah, sure.
Yeah, how to identify the priority of the case? Because every customer wants that his case is the P1 or P2. Okay. But what has been done with me before 2-3 days, Imran and Priyanshu knows that the client is asking for the TAC, and I'm trying to not responding him that he should be go for the TAC. Okay. And I am trying to be done the solution on myself, and it get accelerate. And okay. PP, and there is some problem. So, and that was the SVR. So I think that it should not be a TAC. That you know that safe is high for that IPv4 protocol, and we are trying that MPLS protocol. Okay. I asked you about that in 2-3 days. So okay. How to get the priority of the case? Okay. For ourselves. So okay. We can identify, no, this is the priority 1 case, and I have to reply the client, it is must. Okay. So basically I got this priority. Actually, this priority has 2 things to understand. Means it is not a direct thing. So our operation, if you see our operation is entirely depend upon the customer. Means because we have customer, then we have our operation and our business. Now it depends upon the customer sentiment and customer nature, that what priority should be that ticket on. So suppose if a ticket, for me that ticket is P3 or P4, maybe that ticket for the customer is P1. So not only you have to identify the criticality of the problem, or what is the network outage with that problem, but you have to understand the emotions of the customer. I'll come to this point again. Ideally, P1 means complete network down. Okay. P2 means partial. So 50% of network is up, 50% is down. P3 may be related to some bug or some informations, or maybe some sort of 10% of network is down, or some access switch is not working, or some phones are not working. That means less business impact. P4 is completely information. So customer, they want to implement something, they want some document, they want to know something about SNMP version 3, they know about SNMP version 2, now they want to upgrade to version 3, they want to know this.
They want to know about how the VTP version 3 works, what are the new features of OSPF version 3 or maybe OSPF. They want to migrate from one end to other end and they want some information about that. So according practically or theoretically, you can say theoretically these are the priority. So for P1,
Okay.
entire network is down, means whole business is down. P2 is like 50% of business down, but because they have some redundancy in the network, so their business is running via alternate path or via secondary link. P3 related to some bug or information, P4 100% informational. So this is the severity. But again, a ticket that is P1 for customer, for me it may be P4 or P3. So it depends upon the customer as well, what type of customer you are facing. Maybe I don't know, maybe they are thinking that networking engineers are something like very intelligent, very genius, and they are not working on my ticket and they are working
Hmm.
on some other tickets, so they keep sending you emails. So you can detect the severity of the problem with the emails or maybe the calls that the customer is doing. If the customer is very, very proactive and if they open P3, you think that P3 is P2. If the customer is not like that much, you know that okay, they have to take their own time, they have to do some research, they have to do some backup, you can say the consultancy with the colleagues or something like that. They have to increase their knowledge or they have to open a ticket with a tag with such informations there. At that time they will also wait. But suppose if they are sending lots of emails, phone calls, they are CCing manager or supervisor, that means that P3 is P1 or P2 for them. Okay.
Okay.
So it depends upon whenever you are working on the customer support environment, that is the CSE, the customer emotion is very, very important. And it's very difficult to gain the trust as well. It depends upon customer to customer. Some customer, if you give them solution, they will very happy. Some customer, even if you give the solution, they will not reply anything. So it varies from customer to customer. But ideally the goal should be to resolve the problem. So if you resolve the problem, maybe if the problem get delayed, but if you resolve that problem, if you do the proper documentation for the problem, you are safe. Okay. So general troubleshooting is tips. You can see here that there are different engineers or the cycle for that problem means you can open a tag case, the tag open a case with the BU escalation, that is the business unit. They can communicate with the design or the programming team, then their managers, technical managers, like that. So in all the support role you have such type of escalation matrix. So you have first level of escalation, then second, then third, then finally you are reaching towards OEM. You speak to OEM and then the OEM, they have to provide the solution. So most of the cases our OEM is Cisco, but for F5 TAC and then F5 business unit, and for Citrix likewise all the customers have their own escalation matrix. Okay. So I'm going to discuss this Nexus tool. Before I'll start this Nexus tool, let me pause. NXOS tools. So what are those tools? One by one I'll cover all these things. You can see here different type of things we have, and these things are true with Cisco Catalyst switch as well. You can granular show tech. So but in Cisco Catalyst switch you can't do show tech and then you can't do the filter. In the Nexus iOS, you can do the filters as well. So what is the granularity we can see in the Nexus switch? Apart from that, we have various options related to login capabilities that we can verify. Different type of debugs and redirection, that is true with the Cisco Catalyst switches as well. And then the core file. So what is this core file? Core file is nothing but if the Nexus will crash, what will happen? What type of outputs you have to take? Then you need some core dumps. So with the help of these core dumps, you'll come to know due to which process the Nexus switch or the module got crashed. Then the packet capturing with respect to control plane of Nexus is the ETH analyzer. Maybe you heard about the ELAM tool. ELAM tool is something like you can say the ASIC based packet capturing, where in the Wireshark you are capturing everything. In the ELAM you can send some packets uh, towards the ASIC of particular interface, and it will capture only one packet. Then we have different type of goal test. Then we have this onboard failure logging and the embedded event manager. So all these things are very important, and you will get cases with these things, and these cases are very frequent. Hardly you have any case of Nexus that will not touch all these things. At least few of these things that will touch. So you have to take the ShoTech with respect to some filters. You have to take the logging capabilities. You have to do the debugs. You have, if the Nexus will crash, you have to do core dumps output. You have to collect those things and so on. Let me go down and let me show you something. Now, Nexus is a device that Cisco has invented or Cisco has modified with respect to features. So for all the features, or maybe for a group of features, you have different licenses. So suppose if you want to enable a feature that is OSPF, then you have to enable that feature like feature OSPF, feature OTV, feature LSCP, feature interface VLAN. So you have to enable all those features one by one if you want to enable those features inside the Nexus iOS code. Now suppose if you want to collect ShoTech, now the ShoTech, you can see here that the size of that is something like more than 200 MB, sometimes it is 500 MB. That is quite robust ShoTech in the Nexus switch. So we have option that we can collect the ShoTech with respect to feature. So suppose if you want to collect ShoTech with respect to OSPF, you can type ShoTech and then the feature that is the OSPF. So you can type ShoTech support and then you have number of features. So I'll move this here. I will come to know. So you have AAA, ACL manager, ARP, EVC, and all those features you have that you have enabled with the text file. Okay. So you can collect those outputs. I'm not going to execute this command at the moment, but you have this option to collect the ShoTech. If you want to compress your ShoTech file, you have this option of TACPack. So suppose if you have to send TAC file to the TAC engineers, you can use TACPack, and you can compress in the gzip format. So it is in the compressed format. So 200 MB it will compress to either 5 to 70 MB, something like that. In old code, I don't think so the TACPack is supported. You can see here in this particular version, TACPack command is not supported. But yeah, in the newer code, this TACPack is supported. Otherwise, what you can do, you can collect ShoTech support with respect to a particular feature. Now, because behind the Nexus iOS kernel, it is running Linux kernel, and actually it is the Linux kernel. This NX-OS is nothing but the Linux kernel. So whatever processes you have, so not this NX-OS, behind the C they have some Linux kernel, and you know how Linux work. Linux is the operating system which is capable of doing multi-threading and multi-processing and all those type of multi things they can do. Apart from that, these Linux kernel, due to this Linux kernel, this Nexus box, suppose this is one physical box, you can virtually divide this Nexus box into either 4 or 8 VDCs. VDCs are nothing but the virtual device context. So physically you have one box, but the same box, with the help of port grouping, you can divide that box into at least a group of 8 different box. So that we'll see in the upcoming class. But yeah, that is the feature, that is the robustness of Nexus, that we can do that. Let me pause the recording for a moment. So slowly we'll build the troubleshooting skills over Nexus. But if you want to filter out something out of the ShowTech OSPF, enhanced grip, easy is nothing but the enhanced grip. You can grip something from that, and then it will show the show of that. So let me show you that you can do also this type of filter. So you can type show tech support OSPF, and then you can use pipe. Then you have options, and you can do enhanced grip, and you can include show. Now if you in Nexus, what you have to do, if you want to come out of that thing, you have to type Q. In normal iOS, if you type any key, you will come to the privilege mode. But in Nexus OS, you have to type Q for quit. So now you can see here that we are coming to the original prompt because I am typing Q. So I am coming out. Now what I want to do here, I want to, yes, you are not able to see my screen? Okay, so we'll do one thing. Okay. This is the second session of Nexus, and today I'm going to discuss about the basic architecture of Nexus switch and basic steps, and then how you can do the troubleshooting and what are the basic troubleshooting steps for Nexus. Before starting that, you can see here this is my blog, that is nsublogspot.in. If you go there in the first section of this blog, you'll get some three-dimensional representation of these devices, something like Nexus 7K4, 9, then 10. Likewise, you will get for Nexus 77 as well. Let me expand this bit, this animation. Now how you can use this animation, you can see here this is something 4U rake unit device. This is Nexus 7004, and you have different type of views. So if you want to see the overview of this, you can click there, and it is showing here. So Nexus 7004 slot system is the smallest chassis for Nexus 7000 family. And what are the features you have in this? So what are the things you can do? You can do the ISSU upgrade. You have the feature of fix, that you can add the remote line card in this particular box. They are capable of doing 1 gig, 10 gig, 40 gig and 100 gig interface. They are capable of those interfaces. You can enable OTV, Lisp and MPLS features. You can create the VDCs as well, that is the virtual device context. Now if you want to see one by one all these front cover and back cover, everything, so this particular animation you will get to know about everything. Actually that is 7 rake unit, not 4 rake unit, and it supports SOUP2, 2E, and these are the different line cards. When I will start the Nexus hardware, at that time I will explain you different types of architecture of line cards. But in general, in case of Nexus, you have to understand basic things. So in general we have SOUP2. So I'll write here somewhere in the screen if I am able to write. Okay. So we have, if you are using this animation, then your screen will stuck. Let me check this screen. Okay, no problem. We have, you can see here, we have SOUP2. At the moment we have SOUP2E as well, where you can create 8 VDCs. You have different line cards like F series line card, and you have M series line card. At the moment, the latest one is F3. F series like F1 or F2 line cards, they are simply, you can term these line cards as a layer 2 line card, and M series line cards like M1, M2, these line cards are layer 3 capable line cards. Now at the moment we have F3 line card, that is the mix of both F series and M series, and which is capable of doing all the L2 as well as L3 things. So if you understand these things, like these things are constant for all the chassis, constant in terms that uh, the line cards capability. So you can see here that N7K SUP 2E, so maybe you have SUP 2, 2E or 2E plus. Then you can, if you think about a chassis, so what makes a chassis? So chassis consists of, let me change the color as well. So chassis consist of something called line cards, and they are consist of or contains of supervisor engine. So either it is a Nexus box or it is a catalyst switch. You have something called brain of the chassis. So brain is nothing but the SUP engines, and then parallelly you have line card 1, 2, 3 or 4, 5. So it depends upon which type of 6K or 7K Nexus 7K you are talking about. In 6K the placement of SUPs are maybe different. That depends upon which type of, so suppose 6 or 9. So which type of chassis you are using. Even in the 7K, which type of chassis you are using. So one by one you have to understand the architecture of different types of either Nexus chassis or the Catalyst engine. Now in this particular session I am focused on Nexus, so let us discuss some more things about Nexus. So let us see the supervisor engine of this Nexus. You can see here this is the supervisor slot, and nice thing about this particular animation, if you click on somewhere you will get, oh, what module is this? So this is supervisor 2E module, and you have different places where you can click and you can expand and you can see inside this module. So if you know the hardware level, you'll come to know, oh, this is I don't know where is the RAM slot, but this is the interface slot and these are the buffers. So let me show you, these are the buffer for the interfaces. So for all the interfaces, generally in all the switches, interfaces actually they are mapped with certain ASIC, and those ASICs have some buffer. So these are the ASIC buffer. Now other thing you can see here, let me scroll it down and let me clean this. So you will find different type of DIMM slots. You will find different type of sync power sinks as well. So here these are the buildings. You can see here these buildings are something like power sink for this circuit, and somewhere you will find the memory slot and the other things. Now in this particular supervisor engine you can see here that you have this console port. So we know that why console port is used for. So if you want to connect your console cable directly, you can configure the switch out of box. Even you can use the aux cable. Here you can see that ACT, that is the activation. So this is green or yellow or red. You can check the status. You have different status, something like system, active, power management. So all these things you can see, and here the name of the SUP is written. So this is SUP 2E, and what are the status of this SUP, you can see. Now apart from these things, you can see that in these particular supervisor engine, and this is true for the catalyst as well, you have something called flash. So you can connect your USB here, and if you want you can boot from USB. Okay, after that you can see here we have the reset button here by the end of this. So you will get these informations about the soup engine. So this is one soup engine. Let me go to the other parameters, that is the line cards as well. So this about the soup engine. Now I'm going to discuss about the line cards. I already told you that we have different type of line cards. So what type of line card we have? We have either F1 or F2 or F3, and we have either M1, M2 or M3. So M series belongs to layer 3, F1, F2 belongs to layer 2. This F3 has L2 plus L3 capability, means it will work as a layer 2 of OSI plus network layer as well. Okay, and let me go to the architecture of F3 card. So here you can see this is the F3 card. Now how you could identify the number and marking, because you'll come to know that there are various type of line cards and how to understand which line card is what. So here you can see here it is written like F3 series 12P40 GE. That means it has 12 ports, and each ports, and they are capable of 40 gig, that this F3 card. Then here you can see F248 25 module. That means it has 25 ports, then power supply, then the rear view. So let me go one by one to all these modules. Let me go to the module number, this F3 line card, and it will come up. So it is coming from the bottom of the soup engine. And if I go back, here you have the description as well. So if I click on this, it is showing, oh, what is the engine. If I click here, what I want to know, let me go back, let me redo this process. So I redo this process. I'll go to the F3 card, and in the upcoming class I will tell you that how you can what is the architecture of these cards. So here you can see what are the features of this particular line card. It is 24P, that is port, 40 gig module, and because this is L3 module, obviously it will do L2 as well. See, layer 2 layer 3 module, it is able to do fabric path. It has the fix support. Fix is nothing but this is your Nexus. From this Nexus you can connect with the remote line card. So remote line card, something like 2K series line cards. So these remote line cards, they don't have their brain. So to send or receive the packets, they are using something called VN tag, and they work as a line card. So we'll come to know about this fixed technology. Apart from that, it is capable of doing VXLAN. VXLAN is one other way of data center interconnect, where you have data center 1 and you have data center 2 other side, and you can do the VXLAN over that. Then these are able to do the DCI, that is the OTV, and VPLS, that is the layer 2 VPN, maybe VPLS. OTV is again DCI terminology, where you can extend the layer 2 capabilities of data center across data centers, something like that. LISP is industry standard word of OTV, and the MPLS, they are capable of doing L2 plus L3 things. We'll come to know all these things in upcoming class. Here I am focused only on the architecture or basic of this module. Here you can see in this particular line card, because it has 12 ports, you can see here the model 7K, F3, 12 FQ, 25. So 25, 3 plus 3, you can see here it has 12 port. I don't know why it is 25. 25 maybe its model number, but yeah, this is something like F3 12 port. So you can see here. Now this is very important to understand, that the port grouping of these interfaces. So these two ports are together. This is alone, or okay. So two ports are together. So these two ports are together. These two ports are together. That means these ports are mapped with ASIC. So these two ports are mapped with one ASIC, ASIC 1, ASIC, if you start with 001, 2, 3, like that. So that is again very important to understand that port to ASIC mapping, how it works. Let me scroll down and you have the activity task everywhere. Apart from that, you can see obviously they have the memory sync, memory slots. They must have heat sinks. So these are the heat sinks, and these other things that are inside this module. Okay. So let me go back. We have discussed about F3. Let us check this 48 port module, that is F2 card. Here you can see this F2 card is full layer 2, plus they have some layer 3 capabilities as well. It has low latency, fabric path enable for a spanning tree, free deployment, energy efficient Ethernet module. So that means all these are the Ethernet modules. So if I enlarge this, you can see here, these are the Ethernet modules that you can connect Ethernet module to these things, and they are very much similar to the Catalyst line card. Maybe they are using some properties of the Catalyst switch as well, because in Catalyst also you have such type of features. Okay, so if you count, you will come to know, okay, it will start with, you can see on your screen, 1, 2, 3, 4, 5, 6. So it will start with those things and it will go till there. No problem on that portion. Let me show you one important thing here, and it's very important to understand now what are the port groupings for these interfaces. So from here to here you will see one line, that means port number 1, 2, 3, 4, 5, 6, 7, 8, they have one ASIC. We'll check that. So suppose they are mapped to ASIC 0, then these 4 ports are mapped to ASIC 1, then these 4 ports, so likewise they have the grouping. But obviously we'll check that actually that is wrong. 4 ports has one ASIC. Actually they are in the group of 4. You can see here group of 4. So why I am explaining this, that these 4 port have one ASIC. Say 1, 2, 3, okay, 1, 2, 3, 4. These are the group of ports. They are mapped with one ASIC. Now what will happen? You get some cases like, oh, my interface 1 is not working, 1 2 is not working, 1 3 is not working, 1 4 is not working, but 1 5 is working. That means you have problem not only with the ports, but you have problem with the ASIC as well. So you have to check that what is the port to ASIC mapping. So you will find that sometimes you'll find that, oh, all these 4 ports are not working. From here everything is correct. That means my ASIC is okay after ASIC 0. So ASIC 1, 2, 3 is okay, but we have some problem with the ASIC 0, that ASIC 0 is not for forwarding the traffic towards. So this is the thing you have to check on the interface level. Okay, so I think this is very much clear. You can also have the animation, you have the link. Now let us check the power slot, power supply, and these type of power supply units you will find everywhere. This is the hot swappable power supply. You will get the AC and DC voltage things. You have to check that. Let us see this device in the rear. So here you can see this is the building block of that. This is the backplane design, enables all the module including fan tray, power supply, etc. So this is it about the 7004. This is one of the smallest unit in the Nexus, and that is true if you understand the soup engine, if you understand the line card type 1, line card type 2, it will be very easy to understand any of the chassis, because all the chassis, they have common soup, means they have the soup and they have line card across the chassis. In this particular module we find that we have only one supervisor engine, so the number of supervisor slots will change as per the chassis. So let me go, yeah, let me go to the other. Yeah, please.
Ratnesh,
Mm-hmm.
I have a question.
Yeah, please.
What is SOAP?
What is SOOP?
Yeah.
SOOP is a supervisor engine. So if you see the okay, I'll explain you what is SOOP. Now you have to think like this. Suppose
Uh, there are two SOAPs in the Nexus series.
okay. Could you please repeat
SOAP
your
1 and SOAP 2.
second question?
There are two types of SOAP in Nexus series.
There are two types of
SOAP.
SOOPs in Nexus switch. Yeah. So in Nexus switch we have supervisor engine type 1, 2, 2E. So three types of SOOP we have. We are using 2 and 2E. Okay. So you are asking about
Okay.
what is supervisor engine. So let me answer that. Okay. So if you see the generation of switch. So initially we have something called so switch. We have managed switch, and we have something called unmanaged switch. Unmanaged switch something like plug and play, something like D-Link or any type of 8 or 4 port switch, whatever. Means you can't program, you can't configure, you can't change the capability inside the operating system. That was the unmanaged switch. Let us discuss about this managed switch. So the generation of managed switch will start with some catalyst iOS. So those simple switch, suppose 2900 switch, they come with this facility of the catalyst iOS, that is the cat iOS. Now these particular managed switches, they have something like control plane. Forget about the data plane, but they have some control plane that you can configure these switches. After that, you can see that the 3K arrives, then 4K arrives, then 6K arrive in the switch domain. Now, what happens that these switches, they have only 48 port. With these 48 ports, if your requirement increases, suppose if you need 200 ports, then what you will do? So suppose if you are using 200 ports, because these are 48 port and your requirement is 200 interfaces, then you will connect switch with switch, again 48, then again you will connect this switch with switch, again 48, then you again connect this switch with switch, 48, something like that you will do. That means you need 1, 2, 3, 150, 4, 5 switches. Now the problem here is that all these switches have different control plane. So this switch has its own control plane, this has own control plane. So all the switch. So if you want to configure anything, say if I want to use these switches as a L3 switch or maybe as a L2 switch, L2 in terms of STP, L3 in terms of OSPF. So what I have to do, I have to configure all the switches, because it is not something like that you configure this switch and you can push the configuration on the other switches. You can't do that. So you have to configure all the 5 switches. That was the initial problem. Now you can tell this, okay, so why not we can do one thing, that we can take a stack of 4 switches, we can use a stack cable to a stack between them, and then we have one control to configure all the switch 1, 2, 3, 4. That's true. But what is the throughput of this 2900 series switch or maybe 3750 series switches stackable. The throughput is not that awesome. Means you can use these switches as an access layer switch. You can't use these switches as a distribution layer switch. So distribution layer switch or maybe core layer switch, where you need very high throughput and you need minimum amount of control. So you need control plane to control all the line cards, and you need 10 gigs or maybe 40 gig or maybe 100 gig of line rate. So this type of things or this target could not be achieved with this type of design. So you need some sort of modular switch, some sort of high capable switch which is able to do these things, but you don't need in the independent boxes. You need inside one box. So that is the formation of soup engine. So you need one central brain. Soup engine are nothing but the brain of the switch. These soup engines will take all the forwarding decisions, and once these soup engines will take the forwarding decision, those things will be written down to the DFC cards of these line cards. So once the soup engine is able to understand, they will distribute that knowledge to the other line cards, and then the other line cards they are capable of doing, or they are capable of making their own decisions. Does this answer your question? Why we need soup engine?
Yes, I got it.
Okay. So let me go to the other modular chassis, and that is some big one. So let me choose one big switch, and I'm going to choose that. Yeah. Let me scroll down a bit. Okay. Let us check the bigger one. But yeah, you can go to this particular blog and you can check all those switches and you will find everything. Okay. So what I can do here, you can click here and see, you can see in your screen that how many things are there. We have front view, front door, F3 line card. So in this particular 9 slot chassis, you have F3 cards, you have SUP 2E, you have M2 cards, you have fabric module, and these are the heart of the forwarding engine that we'll discuss when I will discuss about the hardware architecture of a Nexus switch. At that time I will discuss about the fab modules. I'll discuss about each and everything. This is just like I am showing you the diagram of the line cards. I am showing you the diagram of the chassis, how it is, what is the build, and where they are placed inside the chassis. So, and other things that we can discuss over here, that what is the capability of these modules or the SUP engine. So you can see here this F3 card is capable of 48 interfaces, and they have 1 to 10 gig of IO module. IO module is nothing but the line card. So their capabilities is up to 1/10 gig. These F3 cards, they are capable of 40 gig of throughput. This F3 6 port has capability of 100 gig. So 100 gig of 6 port. So 6 into 100, you will get 600 gig. Then the SUP engines, then the M2 card, M2 different card, M2 100 gig, M2 6 port 40 gig. All these things one by one we can check. So let me go to the SUP engine first, and you can check the placement of the SUP engine as well. Let me scroll this and SUP. See, SUP engine was in the top of the chassis. Sometimes they are in the bottom, sometimes they are in the top. And what are the features of this SUP engine? Delivers a scalable control plane, data plane, and management plane services. Provides centralized arbitrations to system fabric, enable distributed forwarding. All these are big terms that we'll come to know in the upcoming classes. But yeah, they are the central what you can say, the central servers, not central server, but you can say that they are the brain of all the line cards, and you will come to know, oh, everything is same, like console, like maybe aux cable, then you have the host port, you have the USB ports. When we go through the architecture of these line cards, then inside this interfaces, how they are mapped with the ASIC, those ASIC, how they are mapped with the central ASIC, all these things will come to know. Okay, but this is the overall architecture of this. Let me go to the F348 port. We have already seen this. These are something like RJ45 connectors. Here also you can see in the diagram. Let me do this, undo this task, and let me scale out this. So even you can, if you go here, it'll tell you everything about this. I can scale out this, and here you can see this. So we have two soup engines at the top. Say obviously you can have one soup engine and it will work perfectly, but for the sake of redundancy we have two supervisor engine on the top, and these two soup engines are full width soup engine. In some of the Nexus switches we have half width two soup engines. So what they are doing, they soup engine 1 and 2 placed here, but in this case this is soup engine 1, this is soup engine 2. Now if I scroll up, then you have this 1 2 3 4 5 6 port F3 card. You can see here that what type of, yeah, F3 6 port 100 gig, and you can see how modular that is. Apart from that, if I scroll, you can see this 12 port card, and it's very difficult to, what you have to do here, you have to check here. So this is F3 12 port, and what is this particular, this is, yeah, obviously F3 6 port. Likewise you have to check by the left hand side of the line card, this is 48 port. Then this is the fab modules. You can see here fab 1 2 3 4 5 6. Actually this is up to 5. Can I open this cage? Let me open this. I don't know from where to open this cage, but yeah, you can open this cage as well. Let me check the fab. Yeah, you can see here how many fab we have. So we have fab module 1 2 3 4 5, and you can see here N7K fab 2. So this particular slots are for fab module. We'll come to know about these fab modules in the upcoming class. Apart from that fab module, you have the power slots by the bottom. So what I want to do, I just want to count down the number of slots we have. So number of slots we have here, obviously 9. So 1 2 3 4 5 6 7 8 and 9. Okay, so likewise you can count the things and what is the placement of the soup engine, where they are placed, the line cuts and all these things. This was the basic architecture, actually the architecture of the Nexus switch. And let me start today's class. So what I'm going to do, I'm going to start from where we have ended last class, so that I have the PPT. Let me open that PPT. What we have done, whenever you are getting any Nexus case, so what are the things that you will check? So the things that you will check, what are the logs you will ask to your customer that I need this log, this log, this log. So those are the things that we are going to do today. Yesterday we have discussed that, okay, what are the things I wanted, and with the help of these things. So if we understand all these terminology like what is the logging capability, how to take show take, how to filter those things, how to filter or how to take captures with respect to CPU, that is the ETH analyzer, how to do the ASIC capture with the help of ELAM, what are the goal tests, what is the onboard failure logging, and how to write EM or how to execute EM inside the box. So all these things are very, very important in terms of identifying the problem with that particular hardware, in this case the Nexus. But this is true for any catalyst switch. Except this, you can't take this, but all these things you can do in the catalyst switch as well. Apart from that, you don't have this filtering capability because Nexus OS is purely using Linux behind the scene. So in the Linux, you have so many features that you don't have in the normal operating system or normal cat OS or normal Cisco iOS, switch iOS. Okay, so I have device with me, and what I will do, whatever we have discussed yesterday, I'm going to skip that, and after that I will start. So let us scroll down. So we have checked. Suppose if you want to take the showtek output, what you can do, if you type showtek, your system will overwhelm with the information. Means in Nexus switches it is of something like 200 MB, and you don't want to do that. So what you will do, instead of taking showtek, you can filter that, and you can take the filtered showtek. How you can do that? I think I have one switch here in my lab. Yeah. Let me increase the font size of this on this switch, and I'll show you. This is the blank switch with no configuration. This is a flavor of Nexus 7K. So I'll show you in this switch that what are the things you can do. Let me increase the font size first, and I think this is okay. Yeah. So what you have to do, because this is one lab device, I don't have any license enable on this. So let me enable the license grace period, so I can enable all type of features on this. So once we enable the license grace period, uh, this particular device will give you 120 days of free feature license. In Nexus Switch, what you have to do, that whatever features you want to run, you have to enable that feature first, and then you can execute that. What does it mean? Suppose if I want to run OSPF, I have to enable feature OSPF. Then only you can execute the commands related to OSPF. Otherwise, they will not understand what is OSPF. Okay. So what I want to do here, I want to take outputs related to showtek. That was the first thing that you are asking to your customer. How could you do that? So for that, you can type simply show tech support, and then you can filter in terms of feature. So suppose I want showtek for OSPF. Now you can see here, we are recording the session. So yeah, good evening. Let me do one thing. What I'm doing here, we have just started. You missed lots of things. Okay. So you can see here that if you run that OSPF feature, then you have those features related to OSPF only, and you can see here in the note that process currently not running, because I don't have other other interfaces or other devices that is running OSPF. So you don't have other things here, but still you are getting lots of messages related to OSPF in this tech support. And what are the things it will show you? You can see in your screen that is just telling, oh, you have these command output. Obviously at the moment it is not running, but show IP OSPF internal event history agency, show IP OSPF internal event history. So these many commands they will execute for you. Show OSPF internal event history LDP, RIB, hello, SPF trigger. all these things, they will collect all these outputs for you. And now you come to the here. If you're not using the, you can mute yourself. If you have any question, you can just unmute it. So apart from that, yesterday we have discussed some other thing about this stack showtek command. Or what is the other thing? That if you want this file in the compressed format, at that time you can use tacpack. So tacpack will give you that file in zip format. So suppose tech1.zz. So you will get the showtek, but you will get in the zip file. So it will that 200 file you will get in 10 MB. 200 MB file, it will compress to 10 MB, something like that. Okay, so you can use that tacpack option as well. Okay, apart from that, what are the other things? So if you want, you can filter as well. So let me do one thing, and this is again very important. Suppose if you ask for showtek to your customer and you find, oh my god, this showtek, I have to filter from this showtek. You have this feature of filtering, the same feature you have in the Linux. So because this is a Linux code, so Nexus has taken this thing from the Linux. In Linux, you can do this day long, whole day you can do this, these type of filtering. So suppose tech support OSPF, and I want to filter something from this. So I can filter something like show here. So whatever commands that are related with the show, you can see here, show IP OSPF VRF, and this is good. Suppose if you don't know what to execute with respect to OSPF, you have all the options related to OSPF. So all the OSPF commands you have, you can see all the show commands, you can copy paste, you can make your directory. Oh, these type of show command I can execute with respect to OSPF. Now you ask me one question, that how could I know that I have problem with OSPF? That if you study OSPF, you'll come to know about that portion. Even the customer will tell you, oh, I have issue with OSPF. Even if you see the log files, you'll come to know that something is wrong with OSPF. Okay, so you have to do other things as well apart from this basic filtering. Now suppose if I want to write something, so suppose if I want to write show run inside my flash or boot flash or USB, I can redirect that to boot flash, and I can give name something like run.txt. Now if you check your boot flash, you'll come to know that yeah, you have this file saved here as a run.txt. Now if you want to check that, no, generally what happen in the customer environment, that you have so many files. Suppose you have 2000 files, and out of 2000 files, if you want to search only this run file, how could you search? Again, you can use the same logic, directly boot flash, and you can use this grep, that is the enhanced grep that include run. So this grep is nothing but to search. Enhanced grep, we are using this enhanced grep function inside the Linux box. You can search a particular name. Okay, so this was the thing that we have discussed yesterday. Apart from that, if you want, you can check different type of logging labels. So you can use directly log flash, and you have different log options as well. If you want to check, if you want to filter something with respect to the uptime of the switch, so you can see here, this is the lab switch. It is up only from last 1 hour. And likewise, if you want to see some other things, you can check that. So suppose if, and this is very important command that I'm going to execute, because sometimes in customer environment, if you type show run, you will get one error there, that you don't have privilege to check the show run. Still, if you want to see that what is inside the active configuration, how could you check that? For that, the option is you can use show file. and if the log flash is enabled, so in this particular switch log flash is not enabled, so that's why it is not showing any option output here. But you can do this log flash and then sup active and then the log. Now in particular Nexus platform, what is the thing that if you type tab, so suppose after show if I type tab, it is completing the show, complete show. I type only sh, and after sh I type tab, show is there, but still if you type tab it will show you all the other options after that. In regular iOS, what is that, if you type question mark then it will show what are the other things after show. But in this operating system, if you type tab, and that is the same thing in the Linux as well, if you type tab it will show you what are the other things. Okay, so no need to type question mark. See, that is the difference between question mark. In question mark it is telling AAA this thing. If you type tab you'll get all these things. So be careful about this. Other thing about this Nexus, that if you type show run and if you want to come out of the prompt, in normal iOS you have to type any keyword, but in Nexus iOS you have to type Q. Q means quit, so you'll come out of the prompt. So these are the very basic things that you have to know, you have to remember. Other important output that you will ask for the customer is show module. Here in this case you can see that I have sup1 that is active. I have, okay, I'll highlight here in the show module with the marker, so you can see here what are the things we have. So obviously in the modular chassis you have supervisor engine and different line cards. So you have line card F248, so all the line cards are F248, means 48 port Ethernet card they are. Okay, so these are the very basic things that you must know. Okay, and if you want to go deep inside all these things, all these events and triggers, so we have already checked one trigger or event here. So let me show you that with respect to OSPF only. But when I have done that OSPF filter, that at that time I have so many OSPF options. So suppose if you want to check the event, it's again it's very important, you have to check the events. So IP OSPF internal and then the event. So the construct of this is something like show IP and then the question mark. That means you have all these options. So it's not only OSPF, it may be RIP, not RIP, but it may be EIGRP, it may be BGP. Do BGP has internal things? So let me type question mark here and then. So about all these things, so obviously AS path is there, that means BGP is there, but BGP, see, I'm typing question mark here and we don't have BGP, we don't have RIP, we don't have EIGRP. You may be thinking, oh, the Nexus is not capable of doing that. It's not true. We have to enable a feature called EIGRP. Once you enable that feature, and then if you type show IP, see, you can see EIGRP now. So because we haven't enabled the EIGRP feature, that's why the EIGRP is not showing up. So suppose show IP EIGRP and then internal, I want to know the internal events with respect to all these protocols. So internal and then the event and event history. So internal and you can see event history and then the event. So here I don't have event with this EIGRP, but with this EIGRP I have other options like CLI, errors, FSM, HA, L3 VPN packet. So let me do the packet. I'm not running EIGRP here in this particular switch. So let me do this with the OSPF. So OSPF internal event history and then event, that is the keyword I was looking for. Process currently not running because I just enable the feature, but I haven't done router, OSPF and process, something like that. So that's why it is not showing. In this particular topology, I have two Nexus switch in my lab like this. They are connected point to point. I am here on this switch. I'm doing only the verification things, not more than that. I enable feature OSPF and EIGRP, that's it. And there are some other features, other default features. So if you type show feature, it will show you what are the features we have on or off. You can see EIGRP is enabled but not running. The other features are disabled, disabled, disabled. So for all these features, you have to go to the global configuration mode and you have to enable the feature. You have to type feature and the feature name. Okay. So these are the things that we have checked actually yesterday. We are not able to complete that. Now let me go to the next slides and please go through these slides. I'm going to post you after the class. So these are the things you can check. Event history you can check. The different type of debug filters you have, but be very careful while you are running the debug command. Please do not run it in the production. If you run this thing in the production, it will break everything. So be careful with the debug commands, and even be careful about the showtech support. So if you want showtech, please do not type showtech. Use showtech with some filter or some feature. Now, if you get cases something related to that, your Nexus has crashed or rebooted, at that time to decode those things you need some crash file. That crash file you can get with the help of core files, that is the show core. With the core files, you will get all these things. Okay. So what command you need, you can see on your screen, show core VDC all. So it will give you, in this case the net stack was the culprit, but it will give you the picture about the crash. Once you have this crash file, you have to open a tag case with Cisco, because they have, the tag engineers have some internal software, so they can decode the crash file and they will give you the exact process due to which process the switch has crashed. Now it's very important to understand this particular output here. So let me copy this and let me go back here. Oh, everything is yeah, we'll see this, no problem. So here, even if I open, I don't want to open anything actually. Notepad. Edit format font. So my laptop, it's so slow. Even I'm not able to do anything with the notepad. That's the gift. Okay, so here you can see the things when you are typing show core and VDC all. You have some numbers and you have to decode these numbers properly. So you have VDC, name of the VDC, the module, the instance, the process name and the PID. It is something like this. Actually it is like this and it is like this. Okay. Now when you are asking for the crash dump, this is the crash dump actually. What you have to do here, that first in this output you are able to see that I have net stack. Now I want that net stack. For that I go to directory log flash module 5, because it is with module 5, VDC 3. Actually they missed something here. This is 3. I missed something here. This is VDC 3 core. So I am checking this. This is my core dump. This is my log file that I want to collect from that switch which has been crashed. Now When you are copy this core file to the FTP server or TFTP server, what you have to do here, copy core /5. 5 is the module number, 6919 is the PID, that is the process ID, and 1 is the instance. So this way you have to do this. There is no other way. This is the template here, that the core, module number, process ID, instance number, and then you have to give the destination. So it's not very simple like you are using this command, something like copy source to destination. So you are not doing like copy what is the source file and that source file you are sending to destination. It's not like that. Source file you have to give the proper path, and then you have to give the TFTP or SCP server. Okay, so be careful when you are collecting the core dumps. Okay. And how TAC is doing that, they have some internal servers, so they will put all those files inside this GUI, or maybe they can do via command line. These are some examples that we don't need to bother about all these things. They will do this. Okay, they have these tools to do that. Okay, so this is it about the basics and the architecture of the Nexus, that what initially you want at the initial level, what types of log you want from the customer, and if you are able to decode all these things, you are able to decode the problem, and otherwise you can open a case with the other teams. Now the next topic is CPU, and let me pause the recording if you have any. Hi friends, today I'm going to discuss a Nexus OS software architecture, and I'm going to perform one basic lab on Nexus devices. I will use this cloud, actually this is dcloud.cisco.com. So I will use this URL or this website for the lab simulation, and this is very good free type of cloud service provided by Cisco, so you can also use for your lab and testings. Let me start the first thing, that is the software architecture of Nexus operating system. You can see in your screen, let me enlarge that. So let me do this thing, this. Okay, so in your screen you can see this is the overall software architecture of a Nexus operating system. Nexus operating system, you can see we have various things here. So what are the things we have? And this is very classical type of example of Linux kernel. You can see in the bottom the kernel 2.6.x means the Nexus operating system, purely they are using the Linux kernel, and that's true actually. They are using the Linux kernel, and during the course of this PPT presentation I will show you what type of kernels they are using. But here you can see how the build of the operating system is. The build of operating system means this is the microkernel here. This is the something like core operating system. On the top of this core operating system, we have different type of stacks. So you can say that we have different type of main programs. Main programs means we have program for networking, we have programs for network interface management, chassis management, and the ASIC management, or the driver or the chip management. These are the horizontal programs you have. On the top of all these programs we have protocols. So we have L2 protocols, L3 protocols, some storage protocols, it's related to a storage area networking, and some other plugins or some other protocols or maybe some other patches available for the future possibilities. If you're not using the if you're not talking, you can mute yourself. Okay, here you can see these two programs are actually very important. System manager PSS, MTS. So we'll come to know that what is PSS, what is MTS, what is message transaction systems. Then SNMP. These things are used to manage the operating system. So we'll see all these things. But yeah, if we see this architecture on the top view, what we can find here, and I'll show you in the diagram area that what we understand from this particular architecture. So roughly what does it mean? So roughly this is something like you have something called kernel. On the top of kernel you have management interface for network, for chip and other services. This is the kernel, suppose Linux 2.6.x. On the top of that you have L2 protocols, L3 protocols, you have some other management protocols. Parallelly you can see that you have two things. You have either PSS, MTS, other stuffs, plus you have SNMP engine for management. Then you have some APIs, some other protocols. Then you have some other management protocols. What exactly happened that when you start your switch, so when you power switch, first of all what will happen, the operating system will boot. So before the boot process of the operating system will start, the bootloader, one small file named bootloader. Bootloader check what are the tables, what are the entries, do I am capable of loading the operating system inside the, you can say inside the storage, inside the RAM. So these checks will happen here with the PSS, MTS and other protocols. Then it will move to the other program, and once you have your switch something called inline, and to be more precise, your supervisor engine is inline, then only you can execute all these features, like features related to L2, L3 management, and at that time they will send their messages to the bottom programs that okay, I want to enable L2 control protocol. So at that time they will trigger something here, something here. This is something like operating system, rough thing. Roughly you can counter like that. So roughly what will happen in case of operating system, you have some global program that is your operating system, and operating system is responsible to manage all the programs. So suppose program number 1, 2, 3. But before starting the operating system, you have some small program which is actually starting the operating system. And once your operating system is up, you can enable all the programs and you can manage via your operating system. It's something like normal Linux type of things. In if you study Linux, you'll understand this process better. Let me go back to the slide, and so one by one I will cover system manager, PSS, MTS and all these things. Now let me go to the other thing and why this particular presentation is here. You can see here on your screen that Nexus operating system runs on modern Linux kernel, and that contains different type of services related to infrastructure, driver chipsets, application protocols, user interface elements. And these are the different versions and the code name for the, actually these are the names for the actual operating system of a Nexus. So suppose if a client is running Nexus 4.2, that means they are using Linux kernel 2.4. 5.0, 5.2, they are using 2.6, 2.6. If they are using 6.2, that means they are using Wind River kernel 3.4. If they are using 7, maybe they are using kernel 4.0. Okay. This CPU and memory architecture I'll cover when I will cover the high CPU things in Nexus. Let me go to the next slide. Now, what you have to know here, or what you have to understand here, that we have two types of a space. One is the kernel space, and on the top of kernel space we have user space. So what does it mean? That you, on the core you have kernel space, so K space you have. On the top of that you may have different user spaces. So what is the use of kernel space? So whatever core things there in your infrastructure, the kernel space is responsible for that, and whatever configuration you have related to the users, that will be done by the user space. So this thing you have to remember, kernel space and user space. And let me go to the other slide as well. I will short all these things. So here you can see that 32-bit architecture and 64-bit architecture. Now one slide is very important. Now you can understand the difference between the supervisor 1, 2 and 2E. So we have discussed in the last session that in the Nexus we have different type of soup engines. Soup engine 1 is using 32-bit. So obviously you can understand that the capability of soup engine 1 is less with respect to the capability of soup engine 2 and 2E, because they are using 64-bit kernel, okay, and plus their capabilities are more than the normal, than the supervisor engine 1. So here these are the basic things that we have studied in our engineering curriculum, that what is the paging and what is the CPU scheduling basics. Basically inside the kernel, these operating systems, they are using round robin to provide process to, or to provide time slides or process or independent process to different services. What does it mean? That your operating system is responsible to manage all the processes. So suppose I have process 1, 2, 3 and they are connected with the operating system. So suppose operating system 1 has given process cycle to 1, then it will go to 2, then it will go to 3, again it will come to 1. Like that they are doing this with respect to round robin, and this is the same thing here, the scheduling basis of that. Okay, let me go to the next slide. Okay, so next slide, KLM, that is the kernel loadable modules, and these are the things. So what you have to do, just go through these slides, and actually all these things are very important when we are doing the troubleshooting, when we are doing the hardware level troubleshooting. So user space and this IO module, something like field programmable array, something like that. So this is nothing but a board of supervisor engine. So we have seen in the last class that we have one board. On that board, I'll show you today as well. We have different type of things there. We have buffers inside that board. We have heat sinks. Obviously we have RAM and ROM and other stuffs. They're connected via buses. So inside that you have USD, you have SSE. So what is the use of SSE? That is the service engine. They are controlling the ASICs. USD is something like you are doing some coding with respect to user space. I'm going to cover this VDC as well, the concept of VDC. I will take maybe 1 to 2 class to explain this VDC. This message transaction services are there. So whenever a process is there, so between 2 or 3 processes, this MTS works. They are taking process or messages from one process to other to other, like that. Then we have PSS that provide persistence storage. We have UTAKER that is controlling the stack or the core collection during the crashes. So this particular function is responsible to collect all the crash infos. These two are responsible for the messaging. So message between suppose line card to sup. This VDC will come to know that this is virtual device context. Inside a switch we can have 8 virtual switch. So this KLM VDC is responsible for that. This SSE is responsible for the ASIC. We'll come to know in the upcoming class that what is the interface to ASIC mapping. And this is something like user space. So upcoming class, these things will be again will get cleared. Okay, let me go to the next slide. So we have some brief discussion about the USD. If you go through this slide, you'll come to know that what is the scope of USD. USD, what they are doing, the user space process isolated and restartability, easier debugging, not subject to something global licensing process, GPL. Now, this is important. So whatever important things are here, I am covering it. This thing will come again and again when we'll do something called ELAM captures. That is the ASIC level packet capture. So you'll come to know in the upcoming class that the layer 2 engine inside the Nexus is termed as a Eureka, and layer 3 engine inside the Nexus is called Lamira. Apart from that, these are the programmable name, or these are the internal name inside the Nexus operating system, and basically all these things are the ASICs, application centric chip, you can say integrated chip something. So all these ASICs are there, and we'll come to know that two ASICs again they map to some other ASIC. Then again you have some local ASIC, they will map to some global ASIC. So likewise they have the hierarchy of ASICs. We'll come to know all these things. But yeah, when we'll took ELAM capture, at that time we'll come to Eureka or Lamira. Means you want to do the ASIC capture with respect to L2 protocol or with respect to L3 protocol. So we'll come to know all these things. And there are some more things related to USD, and there are more things related to kernel ST as well. So let me explain this topology. This topology will help you to understand about the USD and how the U space and K space work. So we know that in the core we have kernel space. Kernel space, we have some service engines, kernel drivers, KLM USD, WD. This is something that is happening behind the scene, and this is something that we are responsible for. So we are doing some configuration with respect to user space, and you may have different instances of USD. So USD 1, 2, 3. Now these are the interrelated process, means the bidirectional process, and you can see the handlers and schedulers and everything. Again, all these USDs are mapped to KSD because they must get instruction via the operating system. That is your microkernel inside this. Let me go to next slide. USD startup, how the USD startup happens. Again, for this I have this callbacks, USD startup callback. This is again very important, and you have to understand this. This is related to our day-to-day work. Now, when you are booting your switch, what happens? So whenever you boot your switch, if you number all these events, you'll find that bootloader will start first. Then bootloader will trigger the operating system to booted into the, they are stored in the flash, from flash it will be booted. After that your supervisor engine will come online, and then your line cards will come online. So whatever line cards you have, they will come online. This is the sequence. These things are happening behind the scene. These things we are able to see that. So what happens? First process is the global process, called once used to initialize or allocate the global structure. Then switch initiate process, called per instance of the device, switch initiate per instance. Then there are hitless processes, called in case of up downgrade restart. Now prepare hardware for testing. So switch is starting. It is preparing the hardware for different type of testing. You may know about this post power on self test, and somewhere here you will come to know about the gold test as well, and for that we have one session on this. So post and gold will come to know. Then they will run different type of DAGs. Maybe you are familiar with this DAG. So if your customer is telling that I have some minor or major issue with my line card, so what you are telling them, okay, I am giving you some diagnostic commands. You run those diagnostic commands and give me the output. After that, I am able to tell you what is the exact issue, something like that. So these diags actually they are coming just after post. So till here, the hardware things means hardware testing will happen. All the core related things will happen, and after that diag, even if you see the gold test or any type of diag result, you will come to know that they are not doing all the diagnostics. Whatever minimum diagnostics are there to you know to make the switch online or to make the SOUP or the line card online, they are doing all these things. After that, hardware initiate to, these things we are able to see. Software final, so hardware portion, hardware programmings or portions are done, then they are doing the software things. Then hardware final, then line card is ready and line card is online. Okay, so these are the process actually happening for any line card, either it is Nexus or it is Catalyst switch. Let me go to the next slide. And yeah, this is also important to understand the flow of the data. So once you start your switch, global, switch init, hardware, post and diag. This diag you can map here as well, means from here you can start. So after diag you can see generic online diagnostic, that is the gold test. I will tell you what is the gold test in the maybe second or third session from now. I will explain all these things. What the gold test is testing, and then your supervisor engine is ready to serve, and now they are online. Okay? So these are the process for all the switches, and because this was very important, that's why I took this thing. Okay, so we are here, and these are the normal slides. I am not going to explain all these things. They are very specific to the hardware, and just go through all these things. I'm going to explain this EOBC. Yeah, that's it. So we are very much done. Let me summarize everything here, and then we'll move to the lab section. So what was the main goal of this particular hardware presentation or the software architecture presentation? That you have some rough idea about the Nexus operating system. Nexus operating system is Linux, a special type of Linux operating system where you have this kernel, then you have different type of interface programs, and you have different type of protocols, means there are daemons for different protocols. Then we understand that what exactly the Linux module or Linux operating system is running inside which type of supervisor engine. So for supervisor engine 1, the Linux version was 32-bit and the version was something 2.0. You can see here 2.4. And for supervisor engine 2E or 2, we have this 3.4. Means it depends upon what architecture you have. If you are using 64-bit architecture, obviously you need some latest Linux kernel. So at the moment you can see from 5.0 and above we are using 2.6 operating system, the Linux image. Now SUP engine 2E, they are using 2 quad core processor. SUP 2, they are using single quad core processor. SUP1 they have dual core processor. Then we have discussed about the KLM process. Maybe in the future you have to do some troubleshooting with respect to all these things. So if you know what is the process behind the scene which is responsible for this particular problem, say if any problem is related to VDC, this process is responsible. If any problem with respect to ASIC, this process is responsible. Any problem with the networking, this process is responsible. Then we have discussed little bit about the user space and kernel space, and these are the specific ASICs that for this I have 2-3 slides, so I will explain you on these things. But yeah, remember Eureka, Lamira. Eureka is layer 2 engine or ASIC, Lamira is layer 3 ASIC or engine. Then this is again very important, USGS startup calls, what happens, how the switch comes online. So this is important. What is the goal test? We'll come to know in the upcoming class what is the goal test. Now the final thing is the EOBC. So what happens that suppose you have this Nexus box. This is your SUP engine. This is your line card 1. This is suppose your line card 2. Now this SUP engine is interacting with line card 1 and line card 2 with help of some sort of buses. So bus services are there. EOBC is one of the bus service that supervisor engines they are using to send instruction or receive instruction from the line cards, or you can say that they are for the communication they are using EOBC. Okay, so this is about the hardware thing. Now I'm going to start the second portion of the presentation, that is the lab section. I'm going to start the second portion of this particular session, that is the lab section. For this particular lab section, I'm going to use one of the Cisco services, that is the dcloud services. Inside dcloud.cisco.com, I'll show you that if you go inside that particular website, if you have your CCU account, what you can do, that you can type dcloud, so cloud.cisco.com. You can you have so many lab already there, so lab topologies and the test, you can test different scenarios related to cloud or security or voice, all these things. In this particular moment I am focused on the Nexus or the data center technology. So for that, what you have to do, first you do log in there. I'll show you step by step how you can reserve your pod or the devices. So please do not use this. You can use something like I'll use my so Ratnesh 721. I don't know what is the password. It will not autofill. I have changed the password so many times, so I don't know what is my password at the moment. Let me try. I'm able to, yeah. So it was successful. Successfully I am authenticated. Let me save my password on this site. Okay. So you can see here you have this dashboard. Inside that this dashboard, if you have some sessions that is going on, it will show you. So what I have done, I have this reserve session, that is Cisco Nexus 7000 for NX OS version 1. What you have to do to reserve these sessions, that you can go to favorite, maybe find contents, and there you have so many things. Now you can scroll down, you go to training and labs, and inside this training and lab you have this Nexus 7000 demo lab. So if you scroll down, you can see this Cisco Nexus 7000 introduction to Cisco NX OS version 1. You can open that. Once it is open, you have this option of schedule. You can click schedule, and then you can reserve for whatever time you have. Generally, by default, they are giving this lab for 4 hours. So if you are using just for 1 hour, what we can do, 23 to, you can change the time to 24. Is it valid time? 24. You can give 23 to 00, that is 1 hour, and then go down, click next, and it will schedule that, or it will book that pod or that devices for you. Once you book that, I have already booked that, so I'll show you how it is look like. Then I'll go to dashboard, and I have these two bookings here. I have already booked this Cisco Nexus 7000 thing. I'll click here on view. You can see here 2 hours 10 minutes are still left for this pod. This is my network topology, but the thing is that if you go to this particular device, that is maybe Windows 7 or Windows 8, if you double click here, you can RDP this device. So if I will scroll this little bit up, you'll get the RDP IP, say remote desktop. If you click on the remote desktop, what you will get, I'm not going to click on the remote desktop, but I have already that. So on the other laptop, what you will get, you will get this. This is my remote desktop. Okay. Apart from that, it's very important to know here. Apart from that, you have other things as well. Other things means, if you go to resources, you have the lab guide for this particular lab that I already shared with you guys. What is the lab guide? If you click here, it will download that, but I have already downloaded that. So the lab guide is, I'll show you the lab guide as well. This is the lab guide. Okay, so for that particular lab, this is the topology. So 3 Nexus devices are connected back to back. Their IP addresses are something like 5.0. This is the topology I'm going to use. 5.0 here, 7.0 here, and 6.0 here. So most probably I will work on Nexus 1 or 2 because I'm going to show you the basic things, basic commands related to Nexus. So this is the lab guide. So I think you understand that how you can reserve a pod for 2 to 3 hours, how you can download the lab material, and you can perform the lab. So important thing is this, that this is not that you are doing only this lab. You can remove the configuration from this Nexus switch and you can do your own configuration. So suppose in this case, in this particular lab, they are running OSPF. You can remove OSPF, you can run EIGRP, you can run other services as well. Okay, so this is one example that how you can perform the lab task. I'll show you the other things, other lab topologies or other lab things as well. So you can create your own topology and you can execute your own lab, or you can perform your own lab, something like that. Okay, so let me enable the putty. Inside putty you can see I have Nexus 1, 2 and 3. Let me start all these Nexus devices. Let me increase the font size so you will also see this. Now for all these devices, the username and password you will get. The username is admin and password is Cisco12345. Okay. So username is admin and password is C1 SCO 12345. This is the password. So what I am going to do, admin C1 SCO 12345. I am logged in. Now, because this is not the actual hardware means that this is not the physical Nexus device. This is something like virtual Nexus device. Inside this virtual Nexus device, Cisco is running some titanium code. If I do show version, we'll see that the operating system is titanium. That is some type of virtualized software that is used only for lab purpose or the testing purpose on for the features of Nexus devices. Okay, so I have started one. Let me start the number 2 as well. So at least I have two Nexus switch. Admin and C1 SCO 1 2 3 4 5. Chain setting, appearance, change, bold and 12. Okay, so I have Nexus 1 and Nexus 2 here. Let me go to the note section. What type of task I'm going to perform. So in this particular demo example, as you can see in your screen, like there are so many tasks that we have to perform, like a task related to the basic CLI, then task related to OSPF. Here you can see in your screen. What I'm going to cover at the moment, I'm not going to cover everything today. When we study OSPF, I will cover this OSPF. When we'll study HSRP in the switch section, I will cover this. So I'll cover basic things like licensing, how the CLI look like, what is the system configuration, how you can check the system configuration, how you can verify the VRFs, how you can do the rollback, or how you can create privileges inside the admin user or inside the other admin operators. I will not use this rollback. This is something like homework for you. It's very easy. You can roll back. It's very similar to the Juniper operating system where you have to commit your configuration and where you can roll back if you don't want to commit. Configuration session is also very easy. So these two things I will never cover. You have to do by your own. OSPF and HSRP I will cover in the upcoming classes, plus the process restartability. Okay, so I'm going to cover these things. Okay, so I have the devices and I have the lab blueprint. Let me scroll down to this particular blueprint, and one by one I will walk you through that. You can also do all these things by your own. You can see here the IP addresses, loopback addresses for these devices are 128.0.0.123. We'll check all these things. The gateway, default gateway is 198.128.1/18. This is important because later what I am going to do, I am going to ping on this particular address from different Nexus switches. So that is, I can mark that this is the gateway. Let me scroll down the admin username, password, system configuration. So how we can check the system configurations and all these things. I'll show you all these basic stuffs. Before starting this, so you can see here in this particular document that we can do the basic testing and basic verification with respect to all these things. Let me go to the Nexus number 2. And do I have the document here? Let me check. So yeah, so this is the document. So what I can do here, that I need a document parallelly, so I can look the document and I can execute the commands. what I can do here, I can open the document here in the local file. Okay, show mod. If you want to check your module, you can write this, you can type this command. What this particular show mod will show you, that you can say unknown module. So what is your supervisor engine, what is your different line cards, because this is something called virtual environment. This is only to test different type of Nexus features. Something like in GNS, you don't have you don't have the physical hardware, but you have the operating system. This is the same thing that we are doing here. So we can able to test different type of features and running configs and etc. But there are some things that some commands or some things related to hardware we are not able to verify it. But anyways, if you type show mod, you'll get the module information. And here also you can see unknown and titanium and everything. Now, with help of show version, you can check the version. So let me show you all these things here itself. Here you can see this is the Nexus OS, and this is for the testing and the study purpose. Now, important thing here to understand that in the Nexus operating system, we have two types of image. We have one image, something called kickstart image, and we have one image, something called system image. Now the difference between this kickstart image and the system image is that kickstart image is nothing but the Linux image, and the system image is your normal iOS for the switches. So because in this particular platform you are running, you have the privilege to run the Linux as well, because we know that behind the scene this is nothing but the Linux operating system. If you want to check the running configuration, you have to type show running config, and by default on the Nexus platform you have one VDC, virtual device context 1, or the default VDC. So here also you have the default VDC. Let me scroll down, and this is the configuration inside the box. So inside the box means here. So if I do show version, I'm able to see the kick images, and if I want to filter, show version, and if we'll begin with kick, these are the images. So kick start and the system image. Show running configuration will give you the running configuration. What are the configuration here? You can see here I have this default gateway. If you know this VRF is nothing but the virtual routing and forwarding instance. Generally in the devices we have two types of routing table. One routing table is something called a global routing table, GRT. Other one is a virtual instance of routing table, that may be local, but VRF, virtual routing and forwarding. So these VRFs are actually the separation of the global table. So inside global tables you may have different VRFs, and by default these VRFs are not communicating with each other. So inside the management VRF, I have this IP route installed. That means this static route, this static default route is for management VLAN. Apart from that, what are the other configurations? You'll get very basic type of configurations here. So all the switches, all the interface, that is the Ethernet 2.1, everything you can see there, they are in the shutdown state. Then you have the management interface. In the management interface, what is the IP address? This is something 133.222. That is the same here for the PuTTY, 198.18.133.222. Then the variable for the boot. So kickstart and the system, and that's it. So you have very baseline configuration here, because this is one virtualized Nexus platform. Let me go back and you can verify all this configuration. So you have the same baseline configuration in the document as well. Now if you want to filter something, so suppose if I want to see only the management interface, we can use the pipe and the section output. So it will show you the management interfaces. I will show you all those things. So we have different type of filters for the running configuration or to filter the configurations. How could you check that? Suppose if you want to check only your management interface, you can type show run interface mgmt0. It will show you your management interface. If you want to know your interface in brief, and if you want to exclude something, you can exclude that. There is no IP addresses assigned here at this moment. Likewise, you can begin with, or you can include something, you can grab something, like that you can do all this basic filtering. Let me go to the next section. Next section is related to VRF, that is the virtual routing and forwarding. And in the previous class, we have discussed about this. Let me recall all these things. So in the previous class, I explained you about the soup engine. In the supervisor engine, we have console port, we have auxiliary port. This is management Ethernet. These are the disk 1, maybe disk 0, disk 1. From disk 0, 1 also you can boot your Linux box. These are the USB port. This is the CMP. CMP, I think they have introduced CMP only for supervisor 1. Now you don't have CMP is one other way to console your Nexus, and for CMP you have different CMP iOS. CMP, this is something like management protocol, maybe chassis management protocol. The full form of this is chassis management protocol. Now this CMP is not there in the SOUP 2 and 2E. You can see here it is only for SOUP 1. So this chassis management protocol is there for only for the SOUP 1. Due to the cost, Cisco has deprecated this CMP iOS. Okay. Now there are something related to VRF. If you want to check your VRF instances, how you can check? You can use show VRF interfaces, and if you want to assign one interface for a particular VRF, you can use that. I will show you that as well. You have this option show IP interface management 0 VRF as well. We can verify that as well. So let me verify till here all the commands, and then I will move further. So if you want to verify your VRF instances, what you can do, you can type show VRF, and if you type question mark, you have all the options, and I want all. Show me all the VRFs. So at the moment I have two VRF, one is the default, one is the management. If I want to know about my management VRF, so I know that my VRF is management detail. So it will tell you detail about that management VRF. If you want to check the management interface, what was the command? Not this command. So management 0 VRF. So the actual command is show IP interface management. This is different form of command. Show IP interface. And then you have option of VRF, and your VRF is management. And if you type enter here, you'll get detail about that VRF, means what is the IP and all these things. So it's okay, you can filter through whatever you are needing in this output. And even you have this option as well, management 0 VRF management, so you can check that. These are the very basic verification things that you can do. At least you have some hands-on on the platform. I know what is my default gateway for all the switches. So default gateway for all the switches are, you can check your show run and you can filter what is my IP route, because all my gateways, all my switches are defaulted towards my gateway. So I can include IP route here. Show run. Even you have other option as well. You can grep IP route. Grep is nothing but the enhance searching thing. You can see here that IP route means that your default gateway is 198.18. If you ping this 198.18.128.1, it will fail. Why it will fail? Because whenever you are pinging to a certain destination, that will try to ping with the global routing table. Here I explained you that by default you are in the global routing table. So you have something called global routing table, GRT. But this default gateway is defined under VRF, and that VRF is management. So now if you want to ping this, you have to ping inside the VRF. So that means you have to change some parameters here. What parameters you have to change? You have to ping like this. You can press up arrow, and VRF is management. Now we are able to ping. Okay? So we are pinging inside the local routing table. The same explanation you have here as well. And note the output of the ping is very like Linux type, because we are running the Linux operating system, so that's why. Now after that, the third scenario is to familiarize about the CLI. What is the CLI hierarchy, what is the dependency, and all these things. Actually this thing is very easy to understand. What it is telling, in the normal routers, in the normal Cisco routers, except iOS XR, if you want to do something, suppose if I want to ping, I have to come out, I have to go to the privilege mode, and then I have to ping. Let me reduce the count to 1. Now in the Nexus operating system, what you can do, you can ping from anywhere, you can check your configuration from anywhere. That means if I want to ping, I can just copy paste this thing. See, I'll increase the count to 15. Now it is pinging here. I can check show run, I can verify anything. It's very much like ASA firewall. ASA firewall again is same as, the operating system is Linux. So you don't bother about go to the privilege mode and do all the testing. You can do all the testing from anywhere. Even from here also, if I try to ping, I'm able to ping. Okay, so this is the hierarchy. Means the hierarchy is not important, but yeah, while you are doing the configuration, obviously you have some hierarchy. So what type of hierarchy you have? While you are doing the configuration, you must follow the hierarchy. And what type of hierarchy you have, you know that. The hierarchy is that, suppose if you want to configure some IP address, how you can configure the IP address. So you have to move from one level to other level. Means you are in the privilege mode, you have to move to global configuration mode. Here, suppose if you want to assign IP address to loopback 1. Then you have to move to global interface mode, where you can assign IP address something like 22222. Now in Nexus, you don't have option of subnet mask. So what you have to do, IP address 22222 slash suppose 32. That's it. This means the loopback address is 2222222 and the subnet mask is 225.225.225.225. Okay, so this, okay, configuration hierarchy you have, but if you are checking the show configurations, show output, you can check from anywhere. Okay, so that is the thing that is explained here. Let me go back to the document and you can see the same here. You can ping, you can verify, you can go to the interface mode. You can assign the IP addresses. These node things are very important, so please do not skip these nodes. You can use the up arrow and get the command line history from the exec mode. Yeah, you can scroll up and down and you have the history of the commands that you have already used. You can use question mark as you are using in the normal normal iOS and normal router switches. You can use this grep to filter something. We have already used this grep or enhanced grep, that is the EG. Now this is very interesting command. So grep minus A3 N is number management. So what this output will do, it will print only 3 lines after management 0. So this type of filtering you can do. Now this tab button is also very important if you want to type something, and this tab button will auto complete that portion. So suppose if I am on the switch, I'm in the global configuration mode. Suppose if I want to configure Ethernet, I will type E and then tab. It will auto complete 2/5. Suppose I want to do no shutdown, I can type no sh and then tab. It will auto complete. So this thing is there in the regular iOS as well. So we have completed section number 1, 2, 3. Those are very basic sections. The last session that I'm going to discuss today is the rollback. It's not rollback, it's actually, this is the role-based access control. Rollback feature is different. This is something like access control for different privileges. So in normal Cisco routers or switches, you may know that we have privilege level 0 to 15. That is, you have 16 different privilege level. 0 is known as a user level and 15 is something like highest privilege level or exec mode. Likewise, in the normal Cisco iOS or switch, you can create different type of privilege. So for different privilege, suppose privilege 1, 2, 3, whatever commands you will give to that customer, he can use only those commands. The same is true for the Nexus as well. You can assign this role-based access control. So if junior admin, if you want to give them only 2 commands, so they can only check the verification and they can only ping those things. You can do all these things with the help of this rollback. And even in our day-to-day activity, we have this thing. So we can't move to global configuration mode, because if you are in the global configuration mode, you can do any type of changes. So we have the privilege, we have the, generally we have the access or we have the privilege to run only show commands. So how could you achieve that task? That task could be achievable per user basis. So you can have different users. For different users, you can have different access labels. So before I'll do some tasks related to that, I'll show you something. Are you able to see my screen? I think my team meeting is not working. Oh, now it is okay. Okay. So you can see here that in your screen, if you type show role, we'll come to know what types of roles you have, and it's very important to understand that by default you have actually four roles in the Nexus switch. So what are the roles? You have network admin role that has all the read-write permission. So he's the admin. He has the admin privilege. You have network operator role, that type is read only. VDC admin, he will do all the things related to only virtual device context. He has also the read capability. And finally you have something, let me scroll down. And finally you have something like, actually I have four roles, and finally you have the VDC operator. So you have VDC operator and VDC admin. So VDC admin will do whatever he want to do inside VDC. VDC operator has only the read option. He can't write, like network admin and network operator. So we have network admin, we have network operator, we have VDC admin, we have VDC operator. So these four roles we have. Apart from that, we can use our own privilege labels, and we can sub-administer, or we can provide the different privilege label. You can see here on your screen that privilege level 15, 14. So all these are default. We can create different privileges inside this. Means we can have different subsets of commands inside these privileges, and we can assign those privilege to customers. So that is the idea. So you can see here also you have privilege level 15 to, let me go up a little bit. What is inside privilege 15? You can see description. This is the system default privilege role. VLAN policy permit everything. Interface policy permit everything. VRF policy permit everything. So here you are seeing the default privileges, they are permitting everything. But once you create some rules, they will not permit everything. And after that you can see the privilege number 0, that they have some commands. I will show you how you can do this today only. Okay, so let us do something. Let us verify our roles and the role feature. So let me show you that, and then we'll create some privilege labels. So you have different roles. This is not good. And show you all the roles. You can change the color as well. If you want some flashy color, you can use that. Whenever I start getting bored, I'll do all these things. Change the color, display everything. Okay, show role will show you the roles. So we have already discussed admin, network operator, VDC admin, VDC operator, and then you have all these privileges from privilege level 15 to privilege level 0. Okay. Show role, and you have feature and feature group. So feature, these features you have for different roles. Means you can create your own role and you can assign these features to that particular role. And what types of feature set you can assign, or feature group you can assign? These. So router, BGP, EIGRP, ISI, and RIP you can assign. Let me go back. So what I'm going to do, I'm going to create one task here according to this particular document, and I will assign that particular user, and then I will log in and I will show you that how you can use this task. So the thing is that create and apply a role. So I'm going to create one role. The role name is Nexus OS Lab role, and to that particular role, you can see here, I will assign some commands. So what are the things they can use? So you can see here, you can create rule 1, that is permit read. permit read write feature CDP, permit command that command and then a star. A star is like anything after ping. So I will create different rule for read. Then rule number 2, you can see here that the permit read write feature CDP. So he is able to understand the feature CDP. Then the number 3 is permit command, that is ping. And then what I will do actually, uh, you can check that particular role and what are the commands with that role. I will log out and again I will log in. So before I log out, I have to create one user in my local database. How you can create that? Username user. Oh my God. Let me go up here. So let me read this thing. Otherwise, we'll get confused. So creating a role is very easy. We will create a new role. So this is the role, Nexus OS lab role, that is allowed to issue the show commands to the check basic connectivity using ping and to configure the Cisco discovery protocol. So I have to allow CDP, I have to allow ping. After creating the role, we will define a new user, Nexus OS lab user, and associate the role to the newly created user. So you have to create this and you have to associate this with this. That is the task. So creating the role is actually very easy. You can create it and you have to create the username password. In this case, we are not using any Takakis or any external server for authentication. So if you create this thing, if you do this line, that means you're writing this inside the local database. Okay. So after that, you can log in to the Nexus device with the user, something called NXOS lab user. Okay. And you can verify this. Okay. So let us do that task. So I am going to create a role. The name of the role is NXOS lab role, and then I will attach that NXOS lab role to NXOS lab user. Okay, and we'll verify the hierarchy and everything. Let me go to the Nexus switch, and to create the role is very easy. How you can do that? Role, and after the role you can give the name. The name is, you can give the name. So NX OS. Let me check the name. You can give any name, but again I am just using this document. So username is NXOS lab user. Role is this NXOS lab role. So NXOS lab role is my role name. Where is my switch? Yeah, lab role, and enter. Now what you have to do, we have to give some rule. So rule 1, and how many rules we can create. Even there is one rule book as well. You can create 256 rules here. So rule 1 is permit. If I type question mark here, you can see we have two options, either read or read write. Read. Per rule 2, you can permit. Actually, we are going to enable the feature, that is CDP. So feature, you have to type everything, CDP, and it is throwing some error. So rule 2, permit. Actually, you have to give read or write permission for all the rules. So here I am giving read write permission for this CDP. Feature is CDP. Then I'm creating rule number 3 for ICMP, and if you want you can give read write as well. So read write, and that is the ping. Do I have that ping feature? I have to check the ping. Let me cross verify the ping feature, because I have to give ping and then a star. So you can also verify your configuration, whatever configuration you are doing. So what I am doing here, I am creating some roles, and actually roles are easy. Inside the role we have some rule, permit read write feature CDP, permit command, and then ping. So I was missing this keyword, that is the command. So that's why the parser was not taking it. So if I go here, and this is the same way you can do this on the regular iOS. So you have to type the commands, permit, and then command, and then ping a star. So here you have to give the whole entire command. That is the same thing we have in the iOS. So we are creating the privilege level, and then we are assigning permit command, and then show IP route, show IP interface brief, something like that. So we are done with this. If we check show role, because you don't need to go out of this mode, and my role is something, I can assign the name as well. No need to do this much of hard work. Name of my role is this. See, you have this option in the Nexus iOS, so automatically we are getting this option. I have this rule permitting. Now the thing is that you can see here, this is something like in reverse order. So I have created my rules like rule 1, then rule 2, rule 3. In the output it is showing 3 to 1. That doesn't mean anything, but just have a look on this. So 3 is the first, 2 is the second, and 1 is the first. This is in the reverse order. So whatever command I have executed, the Nexus iOS has taken it in the reverse order for this particular feature. Okay, so I'm very good with this. Now what I can do here, I have to associate this particular role with user. Then only it will be applicable. So for that, what you have to do, you have to associate this rule with a username. Suppose Nexus OS lab user. I will take very simple thing, but your role should be correct. So go back. I'll give the name. So username is something like test instead of that. After that, it will ask for password. So password I am going to give, you can give any password. I am going to give the same C1SCO12345. It is asking about the role. My role is Nexus OS lab role. That's it. Exit. Now I'm going to log in to this particular box with this user. How you can do it? You can create new session, and for this particular Nexus device, because this will log as a normal user, that I don't want. So what I can do here, I can use this name n7k2dcloud.cisco.com is the DNS name for that login credentials. n7k2. Okay, so I'll go back. I'll give the entire whole name of whatever name is there. So n7k2 dot dcloud, CLOUD. Maybe it's very small, you're not able to see, but I am typing the same thing, dcloudcisco.com. Then it will prompt for username and password. It is asking logging as. Let me increase the font size and then I'll log. Okay, so logging as a test user, that is the test, and my password is C1SCO123455. Now I logged as a test user here. I type show user. What is the PWD? Permission is not there for that user. Means how many commands I have for this user. You can see I have, by default you have the clear and debug, but I have very less privilege. If I type show feature, how many features I have, even I'm not able to type that command as well. But I can do the ping. If I type show run, because I have one default gateway as well, it is showing that yeah, these are the rules for this particular user. But I have very less privilege. If I go to the actual switch here, that has the highest privilege, it is something like network admin. If you type show question mark, you have all these options. Okay, but for this particular user, we have very less privilege. It has a feature of CDP and it has a feature of ping. So if I want to ping to my gateway is 198.18.128.1 and VRF is, I don't have VRF as well. I can't ping to this gateway now. Okay, you can see here you have very less options. So this is something like this. You can't do it. If you give less privileges, then you can't do all these things. Here you will re-verify this. So from the global table you are able to ping. That is from the actual network admin. But if you go to the your user, that is the role you have created, if you log like this as a test user, then your scope will be very limited. Okay, so that is the fourth scenario that I have covered. Do you have any question you can ask? This is the fourth session of Nexus tshoot part, and today I'm going to discuss about Nexus 9K architecture plus high CPU in Nexus 7K and how we can take the control packet captures with help of ETH analyzer. So these are the things I'm going to hit today. I have to take a remote PC. Let me take this TeamViewer. Okay, so first of all, what I'm going to discuss, that is the architecture of Nexus 9K. You can see in your screen. Now, if you go through the architecture of various Nexus products, what you will find that these are very much similar. So Nexus, either it is Nexus 7K architecture or it is Nexus 9K architecture. Behind the scene, they are same. So if you know Nexus 7K, you can easily learn Nexus 9K. If you know Nexus 9K, you can easily learn 7K. These are vice versa. So we have two type of architecture basically. One architecture is something like a single, what you can say, the single line card type of architecture. Means you have some architecture, something like this. Means you have one single box. Let me change the color. In that single box, you may have this type of architecture. You have single box. So this is the example generally with Nexus 5K or maybe some series of Nexus 9300 or 9500 maybe have single line card. But yeah, we have this 9300, maybe 9332 or 93 maybe 56. They have single. So this is not single line card of architecture. But when it is coming to the modular architecture, modular means that you have one big chassis, inside that you have soup engines and you have line cards. So at that time the architecture changes. So if we are taking the example of 7K, in 7K we have suppose 7004 or maybe 9K. In 9K maybe you have 9K18. At that time their architectures are very much similar. Okay, so it depends what type of switch you are having, the architecture will differ. Now we have two types of architecture. Either we have hardware architecture or we have software architecture. I am focusing on the software architecture part because again the hardware architecture part is we can discuss that, but our main area is the software architecture part. If you have any hardware issue, obviously you can raise a tag case with concern team and you can do the RMA for that module or supervisor engine. Now these are the agenda that what is the NX OS architecture. This particular NX 9K, it has some other features as well, means you can use this platform as a SDN switch as well. So that is something like software defined networking you can use. How you can use I will show you in the upcoming slides. Now what is the good thing about this Nexus 9K, that not only you can use this switch as a single Nexus platform, but you can use as a programming platform as well. So you have different type of plugins, means you can write different types of programs, and you can import those programs inside this particular platform. You can see on in your screen that it has let me enlarge the. So it has various features like ISSU, that is common through all the Nexus platform. IGMP snooping you can do in the Nexus in the iOS. First hop redundancy protocol with respect to IPv4, IPv6 you can do. You can create virtual port channels. It has a feature of MST and PVST plus. You can patch either hot or cold. You can do the VXLAN, that you can extend your data center across different data centers. Dynamic buffering monitoring, OpenStack. Again, because this is a type of SDN switch and this is a type of future switch, so you have these options, that these options are very much supported inside the cloud, and you can say that these are the cloud features. VXLAN, OpenStack, maybe other things like they are supporting Python scripting or JSON scripting or other scripting languages as well. You can add with the fix module. Now again, this Puppet and SIF, they are something like SDN controller programming, so they are supporting this as well. XMPP, I don't know what is this. I think this is some sort of bus, but I don't know what is this XMPP. We can search on Google. 64-bit container support they have. So these are the new features we have in the Ashfield.1.2, and these are some enhanced feature that is used inside a data center that this platform has. Then coming to the let me come here. Okay, coming to this particular diagram, I have discussed this in yesterday class, that say either it is a Nexus 7K or it is 9K, you have same type of software architecture. So all these Nexus platform, they are using Linux kernel. There are some specialized type of Linux kernel. You can see here, maybe 2.6 they are running. This is microkernel. On the top of microkernel, we have different programs, different management programs like chip level programming, chassis management programming, interface management programming. Then we have layer 3 protocol stack programming. These are the process. So this MTS is very important. Even this process persistence services are also very important. System manager is important. So what happen when you have iOS? When these iOS will boot first time, they will hit these processes. So they will start the system manager, MTS and PSS. Then it will move to there are a series of things that happens, and your line card and your supervisor engine will come online. If you go through our last session, you'll come to know. I think here also you'll see that. But anyways, these are the two processes which are responsible to load the actual Nexus operating system. Once it is loaded, after that, according to your license, you can enable different L2 or L3 features. You can enable storage area features. You can enable, again, these are some storage area things as well. ISIS DCE is nothing but data center, I don't know, expansion control plane. So you can expand your data center with the VN tag, FCoE, DCBX. Actually, DCBX is used in storage area. VPC. One by one, we'll come to know about all these things. VN tag, FCoE, that if fabric channel over Ethernet, all these things will come to know. But yeah, this is the general architecture of all the Nexus switch, that you have kernel behind the scene. This is something like K space, that is the kernel space, and then you have user space. And users, you may have different instances of users. So user space 1, 2, 3, but all the processes are managed or handled by the core of the operating system. That is the K cell or the kernel. Okay, let me go to the yesterday also I focused on this slide. Today also I am focusing on this slide because this is very important to understand. If you understand these things, then troubleshooting will become very easy. You'll come to know which portion of the things has issues. Okay. Okay, let me go to the next slide. Now again, you can see here that line card software, this is related to line card. For the line card as well, we have discussed in the last class that what happened, that you have something called SOUP and you have something called line card or IO modules. So once the programming will happen in the supervisor engine, those programs, again, supervisor engine with help of some sort of bus, it may be MTS or actually it is EOBC. With the help of EOBC, they are writing those programs into the line card, and after that line card, they are taking their independently they are taking the decisions. Means they are not, giving the burden to the supervisor engine for everything. So in this particular line card software architecture, you can see that they have the forward information base, that is the FIB manager. They have port managers, they have ACL manager, they have QoS manager. So these line cards are capable of doing all these things. If you see what are the difference between the previous slide and this slide, I'll go back to the previous slide. This is a SOUP architecture. In the SOUP architecture, you can see that what are the other things you have in the SOUP architecture. You have chassis management, interface management, and protocol, and you have the protocol stack. In the line card architecture, you don't have those three things, but apart from that, you have all these things. That means whatever features you are enabling inside the Nexus, it is enabled with respect to SOUP. SOUP is responsible of doing protocol stack, means anything related to IPv4, IPv6 things, interface management things, chassis management things. After that, they write those information to the line card, and then line card, they can take independent decision with respect to FIB, port management, ACL, QoS. Okay, so these are the very important thing about any architecture. It's not only 9K, even 7K also have the same things. What are the services you can enable? So services in terms of L2 service or L3 service you can enable, no problem on that. Yeah, this is the modular. There are some other things as well. Whatever important things will be there, I will cover that. Feature manager, you have something called feature manager. What happened in case of Nexus, that you have to enable some feature, otherwise they don't know that what feature is there. So suppose I have this switch here. Let me increase the font size of this switch. And you can have this virtualized switch from dcloud.cisco.com. So from there you can go to dcloud, you can reserve your session for 2-3 hours and you can have hands-on on that. Okay, so I am here on Nexus 7K. Actually this is Nexus 7K, but most of the commands are similar in 7K and 9K and even in 5K as well. If you see what features are running on this particular switch, you'll see some features are enable, some features are disable. So if you want to enable a feature, something called HSRP or suppose EIGRP, you have to type feature and then EIGRP. Now what it is telling, your license is not there. So if you don't have license, you can enable that license, like license grace period. You will get a license for 120 days. Otherwise they have different license like base, advanced and enterprise, and according to your contact with the Cisco you can have those licenses. Okay, so now if I check show feature, now we'll come to know that EIGRP is enabled. It is enabled and it is not running, but feature is enabled. So you have to do this thing, feature and then the feature name, so that feature will enable on your system. Okay, this is the thing, show feature, you can check the feature. Okay, now if you want to check what type of services are running in your system, what you can do, you can check that. So if you want to see that, you have this command that is show system internal, system manager, then services, then all. So now it is telling at the particular moment in this particular Nexus switch, these are the processes or these are the services who are running with the help of this command. And if you type Q, you will come out. If you want to see a particular service in detail, then you can use show system internal, system manager, service, and then you have to give the process ID. Suppose I want to see OSPF. OSPF process ID is 3297. I can copy and paste here and then enter. So it is telling about this particular systems service. Okay. So if you want, you can check the service as well. Let me go back to the slide. Now what is the whole idea why I am discussing these things? Because these things will become very vital in future when you will get some cases where you have some where you have some logs and there are something in the log file. If you know all these things, like if you know that, oh, it's related to feature or it's related to MTS or it's related to PSS, at that time you'll come to know, oh, these things are very important. So let me go back here. You can see sys manager, MTS, PSS, all these things. Even if you go to Cisco Live, I'll give you one link, that is ciscolive.com. Cisco Live also, they time to time they are doing all these things for their clients. Means they have this Cisco Live presentation, I think every month or maybe after every 15 days, there where they are talking about different type of technologies, different type of Catalyst or iOS or Nexus platform, and they are giving very good, what you can say, very good document or very good hands-on or very good presentation over a particular technology. Say I have this PDF, I'll show you what I am talking about. See, this is one presentation inside Cisco Live. So what you have to do, you have to go to ciscolive.com. You have to type this number BRKDCT3100. Even it is available publicly. You can search in Google. So what is the agenda of this particular session in Cisco Live? That They are providing troubleshooting on Nexus 5600 and 6000. Now I'll show you something very important here, and then I'll move to Nexus 9000. Say this is 5K platform. Even if you come here, if you see all these documents, so this is related to Nexus 9K, 7K, 6K, 5K. This presentation or this number. This is related to QoS. This is related to VPC. Like that, you will get very good documents on various technologies. Now, this particular slide you can see here. I am covering. I have covered some portion of these things in my first or second session. Today I will cover the CPU, high CPU and other things, maybe ETH analyzer. Today I will cover that. But yeah, you can see these documents are properly, it's very proper, and you will get lots of information on these documents. Now, important thing is this, that once I complete all my recordings, if you see all these documents, you will find, oh, I have covered all these things. So you must know what is this finite state machine. If one of your cases have such type of logs, what does those log means? So if you know finite state machine, if you know PSS, MTS, if you know EOBC, all these things, then it's very easy for you to understand where is the problem. Okay, so I'll share this document. See, MTS. This is the message transaction services, what MTS is doing. So MTS, message and transaction services to communicate between different processes. So whatever different processes are there, MTS is used to communicate between them. And if you want to check a particular MTS and how this MTS work, you have certain commands for that. So here there is one command, show system internal MTS buffer summary. So it's very important to at least know about MTS. So if you type something like show system internal MTS and then buffer summary, you'll get to know, oh, soup engine with these attributes. So if these things are constant, that means they are good. If they are not changing, that means there is some problem. So they must grow like old or something like that. You will get, if you get such type of cases, come to know all this stuffs. Let me go back. Likewise, you can search with other document and will come to know all these things like crashes. So we have discussed in the last class that if you want to check a particular crash, what you have to check? You have to check the core. So if you type show core, even show system reset reason, so they are very good commands. Show core will show you that where is your crash dump and how you can copy that crash dump to your external server like TFTP or maybe SCP servers. So these are the commands. So it's very good document. Have a look. I'm skipping this because I'm somewhere at Nexus 9K. Okay, so services and all these things. Let me scroll. Whatever important thing will be, I'll cover. Yeah, this is again very important. So Nexus, this particular feature is something like Linux. In Linux, you can have different plugins. Likewise, in this Nexus iOS, you can have different plugins, and that is very good. Means these plugins are something like it. You need not restart the operating system. They are attachable. Once they are attached to the operating system, they will work. So you haven't, in sometimes in I think Windows, if you install some software, you have to restart your laptop or your computer. It's not the same case in the Linux. They will plug in and you need not have to worry about to restart the operating system. You can check the show version. I will cover this VDC, no problem on that. But yeah, you can see all the time we are getting this MTS. That is the messaging and transaction services that is used for communicate between different processes, so it's okay. And this EOBC is important. So two things are important. One is the MTS, other one is this EOBC, because EOBC is responsible. EOBC is nothing but bus, and this bus is responsible to communicate between the line card and the SOOP. So this is important. You have to understand this. Let me go to the next slide. Service, how they are means MTS, how they are sending the messages from one process to other process. This MTS and AIPC is inter-process communication. That's okay. If something will fail inside MTS, you will get some log message. Again, this PSS, that is the persistence storage services. So whatever there in the MTS, it is tracked by PSS, and you can see in this diagram, PSS is storing all the information that the MTS is doing. You can say that PSS is the database of the MTS. This net stack is responsible for all networking related things that again we have discussed in the last session, last class, that yeah, net stack is there. Let me go next, and these are the architecture of this net stack. Here you can see this. This is one of the biggest diagram here. I have to enlarge this, but again, in this particular diagram, you can see that you have different software processes. So OSPF, EIGRP, HSRP. This is something L3 protocols running here, and they are mapped. Say VXLAN is something like related to DCI. This is L2 protocol. Let me just scroll this and close this. Yeah. So L2 protocol you have, and different things are there, but important thing here is to know this MTS, feature manager. These things are the management body who is managing inside across all these processes. So whatever processes you are running, this is inside the supervisor engine. These processes are inside the line card. These are something management. So this is something feature. Now we'll get this PIXM, that is the pixel management something. We will get I don't know what is this ELT stand for. This is Mac move notification, MTM something. So there are so many things you can see that, but this ELT, LTL I know. LTL is the index associated with the interfaces. Ethernet, LTM, I don't know what is this, but yeah, we'll see in the future slide it is there or not. But you have to understand about the PIXM manager, and this is the PIXM. So there are some difference in terms of naming between 9K and 7K. In 7K, if you see the same architecture, you will get something is different. Some process have different names. Okay, this is too much of the hardware. Okay. Now, in this particular diagram, you can see here that the net stack part. So most SOOP processes are PI. They are mapped here. If you see this particular diagram, you will come to know this is something related to the layer 2 plus layer 3 forwarding. So this is related to how ARP learn happens, then how the forward information base built, how the label information builds like that, and how they are written down to the egress of the line card. So okay, we'll see this, but this is the overall architecture. Means inside the architecture itself everything is happening. So supervisor engine, once they know some routes, they are writing those information to the line card, and then line card they are taking the independent decision from source to destination. Okay, let me decrease the size and we'll move further. These things are maybe you will find it boring, but you'll come to know that these things are important. Again, you can see this layer 3 routing protocol flow, and the LTL index is here in the red. And some things that I was not able to explain, if you go through this slide, you'll get that. Okay, and this again, this yeah, slide is important. So this slide, it is showing that single image. Now in the Nexus 7K, we have seen that we have two type of image. One was the kickstart. Kickstart was nothing but the Linux operating system. Here you have single image. Even this 9K platform, actually they have two types of image. One is the single NXOS, other one is ACI image. That is application centric infrastructure that is used in the cloud. So in a box at a time you have single image, but you can boot this Nexus 9K with either NXOS or with the ACI image. You have that privilege, you have that option. Let me go to the other. Recovering the corrupt switch image, how you can recover. You have proper document for that. If you search 9K image recovery process, you will get one good document on Cisco, and you can recover that. But either it is a router, or is it a switch, or it is a Nexus switch. How you are recovering, that you are recovering from the loader prompt. Means you reboot the switch, you press Ctrl+C, you will move to either switch prompt or the ROM mode. From there you have to set the parameter for the flash. If you set the parameter to the flash, you can check the variables are set or not, and then you have to reload. That is the standard way for the recovery for the corrupt images or the crashed images, something like that. See, you can see on your screen that it moves to loader, and then you are booting with this image, and after that you are changing the password. Overall, this is the same strategy on all the platforms. There are some other features as well, and this is the license grace period. If you enable that, you will get 120 days grace in the license. So this is about Nexus 9K software architecture. Now today's next topic is the how to troubleshoot CPU. Maybe you have high CPU or you have CPU related issues. In your screen you can see that a high CPU is a common complaint. But why it is a common complaint? Because everything, by the end of the day, everything depends upon CPU. Means if you have process related things, or if you have interrupt related things, means if it is related to so much, maybe bump traffic, broadcast, unicast, multicast, or it is related to some process, some feature or some process they are not working correctly. So at that time you can have this CPU troubles. In the bottom you can see there are three major things, those are governing these things, the CPU trouble. So traffic that is destined to or pointed to CPU. So if we have unresolved ARP like glean, or if you have TTL issue, that suppose if your TTL time to live value is 1, so obviously it will be processed by CPU. If we have so much SNMP, now this SNMP feature is common in our infrastructure. You have seen that nowadays we are getting lots of cases related to SNMP. The reason behind this, because this SNMP is directly pulling information from the CPU, means they are keep sending the traps, or they are keep sending the request to the CPU. So if you have 3 or 4 or 5 different SNMP servers, obviously you will feel this issue, that the high CPU due to SNMP. ACL processing and programming. Yeah, this is also a big thing, that if you have configured ACL in the wrong manner, then you will face the high CPU. Control plane activity, more common in high scale environment. So yeah, it is not in the common infrastructure, that is the control plane activity. Control plane activity means what? Control plane activity means your control plane is busy with different processes. So suppose if you have very big infrastructure where where your control plane is busy with the routing protocols like OSPF, BGP, it is busy with the multicast protocol like PIM, or maybe MSDP, it is busy with the IPv4 or IPv6 processes. So in the large infrastructure, you'll find that due to so many services or features those are enabled on the switch, your CPU spike is high. In the next slide, you can see here how you can check your CPU status. So you have actually 3 commands to check it. One is show system resources. You can check your CPU status. Now, initially we have discussed with respect to 9K. The same thing you have in the 9K as well, but this presentation is with related to 7K. Okay, here you can see that remember that 7K is dual core. We know that if you have SUP2E, 2 or 2E, they are dual core or they are two dual cores. This is the average between them. That's okay. Now, this thing we know that if we are doing so process CPU history, star means we know that what does the star mean? This is the peak value, and this hash is something like average value. So you have to check that. If you will get a star everywhere, that means what? That means you have some issues. Even if you get hash on the top, that means your average CPU spike is high. Okay. Let me go to other. This is again a neat command to know that why the CPU process is high. In this case, it is showing that we have 24% due to net stack. And what you can do then? So once you understand due to which process or interrupt CPU is high, you can gather the tech support file with the show tech and then the component or the feature name. You can check the event history. Now this particular platform, that is the Nexus platform, they have very feature-rific event history and the log things. So you can have the event history for different features, and you can collect all those things. Let me go to the next slide. Now again you can see there why the CPU is high. Either it is due to ARP or maybe unresolved ARP. Maybe you have fragmented traffic. Maybe you have unresolved ARP, that is the glean traffic. Maybe you have BUM traffic, that is the broadcast, unknown unicast or the multicast traffic. What you can do here, you can check the COP policy. Now in this particular platform they have default COP policy and they have default hardware rate limiter. Now generally what we are recommending to the customer, do not change the COP and the hardware rate limiter policies, because by default they are set to a good value. If you are very good on those COP and those hardware rate limiter things, then only you can change that. Then you can change. But general recommendation, do not change these things. One other thing, this output you can see, this is the big output with the filter option, show policy map interface control plane. I have a Nexus switch, let me run this. So all the big commands you have in Nexus, there is no way that we can escape. Let me go out to this Python. So that was show policy map interface control plane, and and then different type of pipe, I mean the filters. So I can give enhance grip, then drop, then again pipe, class map. What you can do, you can create one template type of thing. If day to day, if you're getting this type of high CPU tickets, then you can refer that notes module and then exclude something. wallet 0 and then conform xn. I don't know what is this will do. I don't know this will execute or not. Yeah. I'll go to the slide because here we don't have such policies configured. But here you can see that if you have something in the drop, means if you are dropping so much traffic, even you can see here the violated action. What does it means? It means something like this. If you have QoS enabled on your infrastructure, so suppose I have enabled the QoS and I have different class map and policy map configured. There something called B sub C, that is the conformed burst. This is conformed, and then you have B sub E, that is the excessive burst. Excessive. Now according to your policy, if you are reaching here, if it is the TCP session, if you reach at this point, it will drop by 50%. Again it will go, it will drop like that. So suppose if you reach here, that is your conform action. According to policy, if you drop, it will drop from here. But generally what we are doing, conform action is okay. Means conform action is, I think some pass or something, I don't know. Some keyword is there, means conform action, if it is reaching here, I'm okay. But if it is reaching here, that is the exceed action, here we are using the keyword drop. So anything that will reach to the excessive burst, it will start dropping. Again it will come down, again the session will restart, again it will reach here, it will drop down. So this is the thing that is explained there in the back. Conform action is okay and the exceed action is to drop. Now here you can see the violate, it is violating something, this much packet, this much packet. So according to the violation, you can edit the class map or your QoS policy, but very few chances you will get these things. Means in the Nexus, these default policies are good, but still if you have some issue with that class map or the policy map, you can change that. In this example, it is showing that you can check the hardware rate limiter for module number 9, and in one counter you can see here the number of packets are dropped frequently. So you can check this output after every 1 minute. If this field is incrementing, that means you have packet drops in the module number 9. Then you can do the rate limit in that module. Okay, so there are other options as well to check the packet drops, and if you have such type of case, what you can do, that you can use these 3 commands. So if you use these 3 commands, you'll come to know, okay, I have something related to packet drops inside the hardware. You can see here, show hardware internal CPU MAC events, show hardware internal stats device MAC variables, and the hardware internal error. So this third output generally we are using in if any type of issue with related to that particular hardware. It will show all types of drop actually. Show hardware internal error. Actually this is very good. In this case, because this is virtualized environment, I'll show you offline this command. I have one physical device as well. I'll come back to this command. Let me go back to the slides. So these are the things that you can check, and by the end of this is what you want actually. if you are not able to understand all these hardware related things, you need these outputs. Okay, whatever we have studied so far in this high CPU troubleshooting, these are these commands that we can check. So you need tech support with respect to some feature, you need system process, you need CPU process history, you need this exec file. You need, if you want to check any QoS policy is dropping something or not, you can check that. If you find that, then you can check the individual classes You can check with the individual module or line cards. You can check the hardware drops are there or not. So these are the hardware drops till here. You can check with the system internal and the packet manager. Okay, and here you can see that, oh my god, if it comes to killing a process to recover, please use kill -6 to create a core file. So again, if you want to do this, please open attack case and then do this. Otherwise something will happen to your network. Today I'm going to start the architecture of Nexus. And in this particular architecture, what are the things I'm going to discuss? You can see on your screen. I'm going to discuss about the chassis architecture. This chassis architecture is same, or you can correlate this with the switch chassis. Then what is the supervisor engine architecture? Supervisor engine, we know that in all this modular chassis architecture you have supervisor engine. Then what about this line card architecture? This IO module is nothing but the line card. So same line cards you have in the switches as well. Then what is the forwarding engine architecture and what is the fabric architecture? So if you see this Nexus box, or even the new Cisco 6800 series switches, what you will find that we have supervisor engines. Apart from that supervisor engines, we have line card. Now this is the chassis. You have complete three-dimensional chassis. Then you have the supervisor engine, that is the heart of the chassis. Then you have different type of line card, maybe 48 port, or maybe it depends upon what type of line card you have, maybe 12, maybe 24. It depends upon their throughput. Then what about the forwarding engine architecture, and what about the fab module? So we'll see about the fab modules as well in this particular presentation. So let us start one by one all these things. So I'm going to start with the chassis architecture. You can see on your screen, let me in the Nexus family, with respect to Nexus 7K, these are the modules. So actually they start with 7004, then you have 9, then 10, and then 18. So 9 means you have 9 slots, 10 means you have 10 slots. Now there is one basic difference between these chassis. So this complete box is a chassis. In the 9 module, you can see they are placed like this, means horizontal placement of the chassis. In the 10 module, you can see that they are vertically placed like this. Again, in the 18, they are horizontally placed. So it depends upon what architecture these chassis have. Sometimes you will feel that they are placed like this, and sometimes you feel that they are placed like this. There is no such a hard and fast rule that which is best, either the horizontal based chassis or the vertical based chassis. It depends upon the architecture of chassis. Means it depends that where you are going to put the power slot, where you are going to put the fan module, where you are going to put the fab module, what is the overall size, means how much rack unit they are going to take. So it depends upon all those parameters, and according to those parameters we have either horizontal based or the vertical chassis. Even if you see this particular slide, you will come to know that we have notes by the end of this in the note section, so please go through it. After that, you can see this 7009 chassis. and this is something like horizontal base chassis, and you have all these things. So the first and second slot, again, this depends that what will be the placement of the supervisor engine. In case of 7009, it is placed at the top, and then you have line card 1, 2, 3, 4, 5, 6, 7. Okay, so you can see here you have IO module slots from 3 to 9. You have locking ejector, so you can lock. This is the front panel, this is the rear panel. Now here in the rear you can see the power supply. Here you have the fan tray. Sometimes you will get some cases where the customer will complain that I have temperature alarm. So on that case we are checking what is the placement of the fan tray, what is the overall cooling in the data center. Is there any other big switch that is kept in front or behind this particular switch? Means, do you have any interference? What is the power supply? All these parameters we are checking if we have the temperature issue in our data center. Now, there is one big discussion over what should be the placement of SOUP engine. SOUP 1 and SOUP 2, you can see here in the 7009, it is at the top. Some of the architect design, what they are telling, that if the SOUP engines will be placed in the middle, and I think most of the chassis you will find that they are placed in the middle. So you have redundant supervisor engine, SOUP 1, SOUP 2. Then what will happen, their communication with the other line cards, so they will be equally placed. So the distance between the SOUP to the line cards will be symmetrical if they are placed in between. If they are placed here at the top, at that time it will be like overburden for the EOBC or the bus structure to carry those information from supervisor 1 to the last line card, that is the line card number 7 or 9. So yeah, it depends. In this case, what we can say, okay, because the EOBC lines are fast, so it doesn't matter, but still in the most of the design you will find that the supervisor engines are placed in between of the chassis. Why? Because then they have the equal distance with the line cards. Let me go to the 7010. 7010, you can see that the supervisor engines are 5 and 6. So this is 1, 2, 3, 4, 5 and 6. It is in between. Okay, and these line cards are equally, they are equal distance from the supervisor engine. Then you have different type of LED status and different type of cabling and lockable front air panel. Obviously you have air exhaust, power panel, fabric module, everything you have in the SOUP engine. So these things we generally keep in the mind. Then we have 7018. In 7018, again you can see that the placement of the supervisor engine is in between, that is the 9th and the 10th slot. And then you have different type of fabric modules. Then you have fan tray for cooling. Then you have redundant power supply. So you can see that this is the best architecture, and if you see different variants of Catalyst 6K as well, you'll find that most of the time the supervisor engines are placed in between the chassis. I think this is this is 7004, and these things I have explained in the first class as well. This is SOUP 1 and this is SOUP 2. Then you have two line cards. This is one of the smallest box available in the Nexus in the 7K family. You can see that they are supporting M1, M2, Now you have to at least understand these things, that what is the SOUP, either it is 1 or 2 or 2E, and what are the line cards. So Are they M series or the F series? Nowadays everyone using F3. F3 has a combination of both M and F. Means they are capable of doing L3 as well as L2. But still you will find that lots of customer, they are using L2 line card, sorry, not L2, F2 line card or F2E line card or M2 line cards. So we have to provide support to them as well. And these line cards has generation. So you can see here in the bottom that we have different type of F series. So F series, I have only one F series line card, that is F132XT. Then in the M series, I have these three categories of line cards. So M132, M148, M148 GST, and the SUP engine SUP 1. Let me go to the next slide. These are the other brand switches, Nexus switch. So in Brocade as well, if you are seeing the equivalency of the Brocade with the Nexus switch, Brocade 87704, that is a 4-slot chassis. Arista also have the Nexus type of capable switch, that is 7504. And these are some marketing terms that, yeah, in the Cisco you will find better throughput. I don't know about cost, but apart from that, you have these features that those are supported in the Nexus 7004. They will not tell you what is the dollar difference, but in terms of feature, you will find the Nexus 4 RU unit is better than these switches of the other vendor switches. Yeah, these are the some things that you can refer by your own. I will share this slide by the after this session, and you can check all the beacons and system LEDs and locking ejectors. These are the power slots, fan tray, and then how much power you need. And even we have one calculator from where you can calculate the overall power throughput, power in the redundancy mode. You have different options for power mode as well. So if one power will go down, other will, so you'll get backup from the other power supply. This is the power budget calculator, that is tools.cisco.com/CPC, where if you give the chassis number, if you give the supervisor number, and if you give the fab module number, it will calculate how much power it needs. Okay, these are the fan modules. So yeah, these fan modules will come to know that in different chassis you have different type of fan modules. So sometimes you will insert these fan modules like this, means in the vertical manner. Sometimes you will insert the fan module in the horizontal manner. So it depends upon the architecture of chassis, that how you are inserting the fan module, either horizontally or vertically. And all these things you can see, either power module or the fan module or the line card or the supervisor engine. All these modules are hot swappable, means you can insert or you can remove these modules and they will not cause any effect, because you have redundant supervisor engine, line cards, you have redundant power slots, you have redundant fan modules. So everything is redundant in the chassis. So that's why if you have any issue with the fan tray or the fan module, you can remove them, and obviously we'll get some alarms that the temperature of the switch is increasing. So you have to remove it and you have to replace it. Again, this is the mechanical view of the fan tray. This is the fan module for 7018. So you can just go through all these things. And again, this is the mechanical view of fan module, and this is good mechanical diagram. So you can see here the airflow, and see, these things are very important, because you will get cases like high temperature or some issues with the IO module. Sometimes your switch will reboot due to high temperature. So you have to understand what is the airflow of the switch. If anything is interfering the airflow, how they are placed means the rakes are the placement of rake inside the data center. Everything will come into the picture if you have such type of case. Again, this is the mechanical view. You can have a look. And in this diagram, you can see the what is the air circulation and how it is coming and how it is going out. Okay. So I am done with this chassis architecture. So inside chassis, what are the things we have seen? Inside chassis, we have seen fan module. Obviously, inside chassis, you have supervisor engine, you have line cards, you have fan modules, you have power supply modules. So everything, if you add all these things, they will construct a chassis. Okay. Now one by one, I will cover the building blocks of a chassis or a switch. So first of all, I will start with supervisor engine. Then I will move to the IO module. IO module is nothing but the line card. Line card, I will cover all the line cards like M1, M2, F1, F2, and F2E. So if you understand M1, you will understand M2. If you understand F1, you will understand F2 and F2E. Okay. If you understand everything, you will understand Nexus hardware. Okay. So let me pause for 2 minutes. And if you have any doubt, you can ask. Okay. So let us discuss about this supervisor engine architecture. And the supervisor engine architecture, you can see this. This is something N7K SOUP 1. N7K SOUP 1, obviously if you see any switch, any router, you have something common. What are the things you will find common? You will find aux port. You will find console port. You will find, if we are talking about 7600 router or maybe 6500 switch, you have disk 0, disk 1. You will find USB slots. So these things are common in all the platform. Here also you can see the beacon lights, then console, auxiliary, management interface, compact flash, then the USB ports. What was different in the N7K Supervisor 1, that they come with the CMP iOS. CMP iOS was something like Linux iOS, and it was different iOS than the NX iOS. So inside this Nexus switch, you have two iOS. One is NX iOS, other one was CMP iOS. CMP, the full form of CMP is Chassis Management Protocol. But for this particular iOS in Nexus switch, they need some other memory buffer. They need some space in the switch, and that's why the cost of the Nexus was high. So what Cisco has done in the upcoming switches, they don't have this CMP interface. So this CMP interface, I think you will get only with the supervisor 1. In SUP 2 and 2E, you don't have this CMP. Okay. Okay. Then these things you will find in all the switches. Now let me go to next slide. And in next slide, you have some description about all these interfaces. So you have description of management interface. You can do out of band management, and they have one management VRF, means the management traffic is inside the management VRF, and you can use the out of band management with this. Then you have the CMP. This is very much similar to the console, but it is running some other operating system, some other Linux Mint, runs right with Linux kernel network stack, but nowadays in the new SOUP, you don't have the CMP. Now in the next slide, you can see what is the architecture of the supervisor engine, and you'll come to know about this fab module. The use of the fab module also I will explain in the upcoming slides. So I have slides for fab module as well, so please do not worry, I'll cover that as well. Now in this you can see here that you have console, aux, management, and all these things. Now from where to start? Okay, so this is your architecture for the supervisor engine. Okay, I will start from somewhere. So in a computing device, whatever computing device you have, what are the things you need? You need RAM, you need ROM, you need some input output. So you have some input, you have some output, you have some process that is termed as CPU, and you have memory. In the normal computing world, you have all these 4 or 5 components. Likewise, here also you will find CPU. You have flash memory. This is for memory. So either it is dynamic RAM, or it is non-volatile RAM, or it is OBFL. I don't know OBFL, but it is flash. So this is RAM, this is CPU. Forget this security processor. Internal CF, link encryption. So this is basically used for Mac security, this link encryption. So you can think like this. So you have memory, you have CPU. This CMP has their own thing. So this CMP, chassis management protocol, has their own RAM, has their own flash, has their own physical interface. Okay, so let us exclude this because in the new supervisor engine we don't have this. But if we have CMP, means they have their own memory, their own flash, their own input. That is the physical interface. Here you can see you have this input, physical interface. This is the again the encryption. This is a specific ASIC for the Mac security. That is the layer 2 security feature inside the Nexus. Now with this CPU you can see that RAM and flash are associated, and then you have system controller. So this system controller, what it is doing, this system controller is mapped with the port ASIC. Replication engine is basically doing multicasting thing. Then you have fabric ASIC. This EOBC is nothing but the communication engine between the supervisor engine and the line card. So whatever instruction that is going from the supervisor engine to the line card, it is done via EOBC, and this is vice versa. Then you have fabric modules. Then you have virtual output queue. Then you have central arbiter. Now, what is the use of fab module? That is again a good question. What happens when, suppose you are the customer, you are sending some information via interface. Obviously, if you want to send some thousands or millions of packets, what will happen? First packet will go to the supervisor engine. Supervisor engine has their own specific ASIC. They will do something with that packet, maybe in-cap or decap with that packet. Then one of the copy they will send to the fab module. Now fab module or the fabric module is the module which is providing the speed inside the switch. Means when we are talking about that I have 40 gig interface or I have 100 gig interface, you know this thing, your interface, either it is optical cable or maybe Ethernet type of thing. This is your internet interface where you are plugging the cable. This is 40 gig. Who is providing this 40 gig? Interface is not providing 40 gig. Even this CPU is not providing the 40 gig. This RAM, DRAM, they are not providing the 40 gig. This port ASICs, they are not providing the 40 gig. The fab modules, they have the crossbars inside that. The fab modules are providing the 40 gig of throughput. So whatever speed you have in your switch, that is due to fabric modules. Okay, so what happened that your request will go via ASIC via fab module, and then from fab module it will go to the specific line card, or from source to destination. So behind the scene, whatever A to B processing speed or throughput is there, it is due to the fab module. We'll come to know about the fab module. But if you know this architecture, you'll find that same type of architecture you have, less you have in the catalyst switch, less than this. Even if you exclude some port ASICs or something from here, you have the architecture of Catalyst, or you have the architecture of Nexus 9K, and you have the architecture of ASR 9K. So all those architecture, they have less complexity than this particular Nexus architecture. Okay, so if you understand this architecture, you will understand other architectures as well. Let me go to the other slide, and this slide is specifically with the programming label detail we have in this particular slide. This is nothing but this one. So what is the name of programming name of this port ASIC? What is the programming name of this fabric ASIC? You will get to know here. And this is true with the ASR as well. In the ASR also, you have the same ASIC names. So in the ASR also, you have Metropolis, you have Octopus, you have Santa Cruz, like that. Okay, so what I will do here, I will just make these things easier. So what happened? You have interfaces in your line card. Suppose here we are talking about the supervisor engine. So suppose you have interfaces. Generally what happens, these interfaces are mapped with the ASIC. That is the application-centric integrated chip. Now these ASIC, so ports are mapped with ASIC. Now these ASIC are again mapped with the central ASIC. And again these ASICs are mapped with the fab ASIC. So everything in the switch, you can come to know it is due to the ASIC. So these application-centric chips are very, very important. And nowadays these ASICs are programmable. So if you are using programmable type of ASICs, then only you can do all these data center things, like you can do fabric path, you can do VXLAN, you can do ACI integration, all these big terms you are doing. Why? Because you have very good programmable ASICs, and most of the cases, all the vendors, they are using Brocade ASIC. Brocade. So Brocade, or there are some companies, they are making these ASIC chips, and they have a specialization on the ASIC chips. They are building these chips, and we are getting such a throughput and new features that will be programmed inside the ASIC. Let me make this slide little bit complex. Again you have the again you have this supervisor engine, and now you can understand this, that this is bit easy. So this is actually supervisor number 2. Last time we have discussed about the supervisor engine 1. So there is some difference between supervisor 1 and supervisor 2, and if you don't want to focus on sup 1, just forget it, because sup 1 is very old now. So focus on sup 2 and sup 2e. Now supervisor engine 2, and we have seen in our last sessions or previous sessions that this supervisor engine has quad core processor, and supervisor engine 2e has dual quad core processor. So here you can see that they have only CPU 0. If I come to supervisor number 2e, you will get CPU 0 and 1. Okay, again you will come to know that all these interfaces, they have input output controller. Then you have the boot flash associated with that. These Ethernet MAC they are connected here. It's very difficult to understand this architecture. See, difficult in terms of, because this is not exactly what it is. Inside this architecture you have so many modules. So what generally we are checking here, that what is the fab ASIC and what is the interface ASIC. So if you refer the last diagram, this one, this is actually better than this diagram. So you'll come to know that the local ASIC is R2D2. That R2D2 is mapped with the Metropolis ASIC, and you have central ASIC, that is the Octopus, and you have fabric ASIC, that is Santa Cruz. Okay, so local ASIC, common ASIC with the port, then you have central ASIC with all the ports, and then you have fab ASIC. You can understand this architecture in terms of ASIC. Now, one new thing that in this supervisor engine is SOC, switch on chip. So apart from the supervisor engine, we have this SOC chips as well in the SUP. And again, I'll tell you, just divide this supervisor engine into CPU. So we must have CPU. Let me start from bottom. So I'm going to do this thing. I'll create one slide here in between. Let me do this. Yeah. And see here that you have interface. Think like this. These interfaces are mapped with ASIC. You have somewhere inside your supervisor engine, that is CPU. These CPUs are mapped with RAM. They are mapped with some flash. These ASICs are again, number of ASICs, they are again mapped with some central ASIC. These are again mapped with the fab ASIC. And that's it. This is the architecture of all the switches and all the Nexus. But yeah, but still we have to understand all these things, pieces. Okay, let me go to the next slide. And here you can see that everything is explained. So what processor, what is LinkSec, USB flash, and everything. If you have time, just go through with all these things. Okay. Yeah, you can go through all these things. And they are adding some more features on the supervisor engine, on the line cards, on the throughput, everything. So everything is enhancing nowadays. And you can see here the difference between the SUP2 and SUP2E, that inside SUP2E we have 2 quad-core CPU, 32 GB RAM. In SUP2 you have only 12 GB of RAM and it is quad-core. So still they are on the way to achieve some more throughput, some more process cycles. And this is one of the better slide. So here you can see what is the difference between SUP1, SUP2 and SUP2E. And the iOS 6.1 and later, you have this 2 external USB slot with 8 GB expandable up to 2 GB, 32 GB of RAM, 2 into quad-core Intel Xeon processor. Okay, you can go through all these things. So I'm going to stop here after 2 slides, and then we'll discuss some points related to Nexus chassis and supervisor engine. Okay, so there is one question, that why do we need 2 new supervisors? Isn't this just a CPU and memory? And what is the difference between the supervisor 2 and supervisor 2T? Now the first question, answer for the first question. Yes, it is more CPU and memory that enables the higher scale of SUP2E, while the premium of SUP2E may not be significant in a large deployment. We want to provide customer option. So we need to, just we want more throughput. So if you go through this, they are telling, and again, they are selling their supervisor engines, and they will tell that this is the next gen SUP, so you can use. It will support some new features, some new enhancement. The second one is important. What is difference between supervisor 2 and 2T? Now this 2T is for Catalyst. This supervisor 2 is for Nexus. So in Nexus you have SUP 1, SUP 2 and SUP 2E. In Catalyst you have supervisor 32, that is legacy nowadays. Then you have SUP 720 and then you have SUP 2T. Even they have introduced SUP 60 as well. So T in terms of the memory. So 2T is 2 terabytes, 720, 6 terabytes, something like that. So T in terms of their throughput. This is the difference between the Nexus SUP and the Catalyst SUP. So in the upcoming class, I will show you the difference, exact hardware level difference between the Nexus switch. So in Nexus switch, they have different type of ASICs. Those are mapped. In the Catalyst switch, in the Catalyst supervisor engines, actually they are not that much complex like Nexus supervisor engine. The Catalyst supervisor engines are like very simple. Once if you understand this, you will find that the Catalyst supervisor engines and the IO modules, that is the line cards, are very simple to understand. Okay. Let me go to the next slide, and in the next I will explain the IO modules, but I'm going to stop here. If you have any doubt, you can ask. This is part 7 of Nexus, and today I'm going to cover M2 cards and the forwarding inside the M2 cards, and plus I will cover some other things inside Nexus switch. So let us start the session. Now this is one of the most important slide for Nexus. With help of this particular slide, you'll come to know that how exactly packet is forwarding inside the card. Now you can see that packets are going automatically. They are hitting the fabric ASIC and so many things are happening. So one by one, I will cover each and everything in this particular slide. And by the end of this particular slide, you have at least idea that how the forwarding happens and what are the importance of different ASICs. Again, I have one more slide. That slide will focus inside the L2 and L3 engine. So yesterday Shashi asked that question, that how the lookup happens inside the L2 L3 question. So today I'm going to answer that as well, this L3 engine and this L2 engine. Now we'll see that how roughly when a packet ingress from one interface, how it will cross different ASICs, how it reaches to the fabric ASIC, that is the core of the forwarding engine fab module, and then how from fabric ASIC again it will come in the reverse direction and it will egress. So this is ingress and this is egress, will come to know. Now you can see 1 2 3 4, it's quite descriptive here. So packet number 1, that is the one. Traffic flows receive from wire. So from wire the traffic is coming inside. Link sec, some sort of tagging is happening. Link sec is nothing but layer 2 tagging. Then the ingress port QoS, will come to know all these things. So when a packet is coming, that ingress QoS is working on that. Now this particular packet can, if it is a multicast traffic, it will hit replication engine. If it is not, then it will go to either L2 or it will go to either L3, depending upon what type of packet or frame it is. If it is a frame, obviously it will go to L2 engine. If it is a packet destined to some unicast routing, at that time it will hit to L3. So you can see on 4th number that looks at the L2 L3 contents of the flow and the hash between the 4 links replication engine, creates a header for each packet source port is header is listed, destination port field is blank. So what now this particular step number 4 will do, that it will check the header. So header is something like you have something called payload, that is the data. Along with the data you have some header field. Now 5th number step, store packet and submit the packet headed for lookup. So this is very important to understand that entire packet is not going for lookup. So what this particular ASIC will do, that they will store the data, they will split the data and header, and only header will forward it towards the lookup engine. Header sent to the forwarding engine. Now the header is going towards the forwarding engine, in this case that is URL 8. Return results with destination. Now we'll come to know that what is exactly happening inside the URL 8 in the upcoming slides. But after all the lookups, means after L2 and L3 lookup, the ASIC has stored the data and they have sent the header for L2 or L3 lookup. Once the lookup is done, a return result with the destination index 3-bit RBH, that is the write bit hash. So they have done some sort of hashing. 10th number, you can see this is the parallel queue. This is a parallel virtual output queue. We'll come to know its VOQ importance as well. So what is VOQ? We'll see that in the upcoming slide. But it's some sort of virtual queue where you can store a packet. Now VOQ, arbitration and queuing. After that, this packet will move to the fabric ASIC. So here you can see that they are doing some sort of credit to the fabric module, and the fabric module will send a credit for all these headers. Now till 12 we have done one way of transportation. In 13th number you can see that fabric module receive from return. So what it is doing here, we are sending some credit. You can say that credit in RX direction, and those credits are, means in the transmit direction they are checking. So now the fabric module is checking those credit in the egress direction. After that they are checking the return credit pool, that is okay. Now what will happen, the packet is going in the egress direction, then they will check the egress policies, maybe QS policy, maybe other policies. Now what they will do here, that they will remove some header from here, and they will do some read write of the layer 2 or maybe layer 3 header information, and then the link sec, that the removal of the tagging will happen here, and then the traffic flows to the destination. So this is a overall picture that exactly what happening here. So you can see here that packet is coming to the ASIC. What ASIC is doing, they will store the data, they will send only header to the forwarding engine, and when we are taking the ELAM, that the embedded packet capture, we are taking ELAM with respect to URL engine. At that time we are checking only the header of the data. So that's why the ELAM captures are giving very good results. Now from here the packet is going somewhere to the fabric ASIC. After all the lookups, fabric is checking what is the input credit and what will be the output credit. According to that they are sending the packet in the egress direction. In egress direction again they are doing the QS in the egress direction, and then the reversal of MACsec, that is the Cisco Trust Sec. They are checking that, and once Cisco Trust Sec is checked, packet is finally going into the wire. So packet is coming from the wire, packet is going inside the wire. This is the overall picture of a packet flow inside M2 card, and this is very much similar to the M1 card as well. Even in all the modules you have the same feature, that the packet will come inside, it has some lookups, then it will go to the fabric and the return will happen. Only thing will change in the other platform, that maybe you have different ASICs. Maybe you don't have virtual output queue, maybe you have some other type of chips inside the card, but overall this is the thing. So packet is coming input, ASICs, they are doing the lookup with respect to either L2 L3 engine. Now they are moving to fab ASICs, and from fab ASIC the reversal of whatever in this direction, the reverse of that will happen. This is the overall packet life inside the box. Okay, so let me go back. Yeah. This is the blank. By default, this is blank. Okay, then what is this slide? M1 output. This is M1 module architecture. So overall, whatever architecture, either it is M1 or M2, you can understand that. And one question I think you asked me yesterday, that you asked about this ASICs. So R2D2, Metropolis, Octopus, Santa Cruz. Answer is that this R2D2 is directly attached with the links. This Metropolis is nothing but the replication engine. This Octopus is the, you can check what is the Octopus. Just after the let me go back. So there are different ASICs. This is not an ASIC, this forwarding engine. This is forwarding engine. So if some buffer is connected with the forwarding engine, that we have to figure out. Let me answer the question and then I'll go further. So we have checked that R2D2 bus. Let me pause the recording. If you have any question till this point, now you can see here the mixing of different type of cards, then how you can port channel with these cards. So M1 to M2 is correct. Means one side if you have M1 card, other side M2, M1 M2, you can form the port channel. M1 and M2 will not form a port channel. F1 and M2 will not form a port channel. F1 M2 will form the. So these are the things that you have to keep in mind. But nowadays we have the F3 card, so we don't need F1, F2 or F2E or M1, M2. Directly we can use F3 for everything. So one side F3, other side we have F3, and there is no problem of forming the port channels. Okay, but yeah, there are so, this Nexus platform is very platform dependent, so you have to know these basic stuffs. Okay, let me go to the next slide. Again, the same thing, that is the RMOS. So RMOS means R2D2, Metropolis, Octopus and Santa Cruz. So these are okay, they are directly mapped. This is actually mapped in this direction. This is the fabric module, R2D2, Metropolis, Octopus and Santa Cruz. For other line card, you may have some different architecture, but moreover the target is the same, that the movement of the traffic is something like RMOS. Now I'm going to start the discussion for F series card. F series card has one feature or one different type of ASIC that is termed as SOC. So we'll see that. Before that, you can see that what is the input queue. So you can see 4Q4T means in the receive direction you have 4 queues. So Q1, Q2, Q2, Q3, Q4, and they have 4 threshold value. So T1, T2, T3, T4. So T1, T2, T3, and obviously T4. So you have two type of QA structure. Either you have 2Q4T. So 2Q4T means 2Q and 1, 2, 3, 4, 4 slices. In the transmit direction, you have one priority queue. You have three. Actually, priority queue is also one queue. So you have 4 queues like this, and you can see only one threshold. But one queue is priority queue. So this is reserved for voice or any real-time traffic. So like that, these are divided. Now let me go to the architecture of this F card, and F card you can see here that Cisco has introduced SOC, switch on chip, and that SOC are actually less expensive than the M card ASIC. So in M card ASIC we have seen that we have different type of specific ASICs. Here the design is very simple. You can see two interfaces. Suppose this is what type of line card? This is 32 port. Yeah, this 32 port 10 gig F1 series. You can see here that how they are mapped. So two ports are mapped with one SOC. Again, two ports are mapped with one SOC. Like that. 16 ports are mapped here with one fabric AC. 16 ports are mapped with other. And finally, they are mapped with the ASIC, fab ASIC. So you can see your architecture drastically enhanced, or you can see you have very less complex type of architecture in this case, and that's true. So with the introduction of this SOC, switch on chip, what are the benefits we have? So each SOC manages two front panel 10 gig port. That's correct. One SOC is mapped with two ports. SOC design increase the performance while lowering the power, cooling, and the requirement and the cost. So they enhance the performance. More features will come in the future. Contrast with M1 line card module architecture, which consists of many purpose-built ASIC and ASIC chipset, each with external memory components interconnect. So M1 cards are like so complex and expensive. So the solution is the F card, and the F card you have SOC. So these less expensive chips are mapped with a 2-port that we have seen with the 32-port line card, and we'll wait for some time. And let me go to the other slides. These are the benefit of SOCs. Obviously we can have benefits. Now coming to the next line card family, that is the F2 line card. In the F2 line card also you will find the same type of mapping. So before checking the F2 line card or F2E line card architecture, let us see what are the differences between the family of M series card and the F series card. So you can see actually the F series cards generally they favor L2, and M series card they favor L3 traffic. Here you can see F series card, they can hold up to 256 MAC addresses, I suppose. You can see here this particular F card. F card has more features with respect to L2 features. They can hold up to 256K of MAC addresses. Even F2 card hold up to 16K to 196 MAC address. M card only 128. They are layer 3 capable. F1 is not. F2 is yes. Full support of NetFlow, no. Less support of NetFlow. ACL up to 128. PIM and all these features you can see here. So this M card, actually M1 card and actually M2 card, these cards are more favorable for L3 type of traffic, and F card, F1 card specifically, they are used for L2, but now we have F3, and F3 is a combination of M and F. So in F3 card you have the mixture of both the features. Now let us see the architecture of this particular line card. They have added some features like Lisp, bidirectional PIM, MACsec, IPv6 DHCP. Some other features are also there in the F2 card. These are some specification you can see. Now this particular slide that I skipped, this is again very important to understand about the trans receivers and the 10 gig UTP cable. This is UTP cable. Okay, so it's not like all the time copper cables have the capability of 10 gig. Sometimes UTP, something untwisted pair cables, these are the copper cables and they are directly connected with the interfaces. Okay, so they have RJ45 connectors. You can see 1 gig base T and 10 gig base T. So keep in the mind that they are also capable of doing 10 gig, the UTP cables. Let me go to the next slide. I think I don't have architecture of this or not, I don't know. If I don't have architecture, I will open Google and I'll show you the architecture of F2 line card. So no problem on that. This is the overall difference between M1, M2, F1 and F2 series card. Forwarding engine. So I think I don't have the topology, the internal architecture of F2 card. So let me open Google and I'll show you that architecture. And again, this F2 cards and plus the F2, I'll show you the F3. I think F3 line card we have. So F3 line card or maybe F2E line card architecture. Because this F series line cards, they have introduced the SOC, the concept of SOC chip. You can see here 7700 F3 line card. Let us see the F3 line card architecture. Okay, this is F3 line card architecture from Cisco Live, and in this particular architecture you can see that ports, they are mapped with SOC. So 8 ports are mapped with SOC. This is 48 port. So 8 into 1, 2, 3, 4, 5, 6, that is the 48 port. And they have, you know, this type of redundant mapping. So they are mapped redundant fashion with the ASIC, and these ASICs are again mapped with the fabric ASIC. Okay, so in F series line card you have this architecture that ports are mapped with the SOC and they are mapped with the fabric ASIC, and that's it. So that's why they are the easy design, and nowadays we have F3 card. So F3 card has both the feature of F1, F2. Let me go back to our discussion that we are discussing something, and I'm going to move to the next topic, that is the forwarding engine architecture. Forwarding engine is nothing but we have seen the L2 forwarding engine and the F2 forwarding engine and how the lookups happen inside the forwarding engine. So you can see here what are the things that has to be checked inside L2. So they will check the ingress, egress, source MAC, destination MAC lookup, hardware MAC learning, IGMP snooping, and the IP-based layer 2 multicast constraints like IGMP. In layer 3, IPv4, IPv6 layer 3 lookups, ACL, QoS, NetFlow, other processings, linear pipeline architecture. Okay, so we'll see this pipeline architecture, and again this is the second most important slide we have in this particular topic. So let me go to this bigger slide, and we'll spend some time here to understand this. So now you can see this is the forwarding engine. So what is happening actually, that the packet is coming from somewhere, it is reaching to the MACsec. So packet is ingressing, it is coming to for MACsec or CTS, then it is going to R2 D2, and then it is going to replication engine. Replication engine, if it is if it is multicast traffic, a replication engine will take decision, and further it will send to either L2 or L3 engine. Otherwise directly the packet will go for L2 or L3 lookups. Again, remember that packet is not going towards L2 or L3, only the headers are moving. So whatever headers are there, they will move to either L2 or L3. Now how the lookups happen and what are the stage of lookup, that we can check here. So packets headers from, you can see it is written like packet header from the IO module. Now see, check this. Okay, so ingress pipeline and we have egress pipeline, that the packet is coming in and that the packet is going out. So packet is coming from L2 engine. So L2 engine, what type of lookups that is doing? The ingress MAC table lookup, IGMP snooping lookup, IGMP snooping redirection lookup. Then it is checking the reverse path forwarding. So do we have reverse path forwarding configured, or it is doing that check? Ingress ACL and QoS classification for the incoming packet. Then the net flow. Now when this particular incoming packet is going to the outgoing direction, or the ingress pipeline, when this ingress pipeline is moving towards the egress pipeline, at that time what they are doing, and this type of tickets you will get quite often, that FIB TCAM adjacency table lookups for layer 3 forwarding and ECMP equal cost multi pathing hashing multicast reverse path forwarding check. Now there is one important thing here to understand, that for all these type of services like ACL, QoS, NetFlow or IPv4, IPv6, you need a specific MAC address. A specific MAC address means you need some MAC address to hold this information. So suppose if due to any reason, if NetFlow is using more number of MAC entries, or your ACLs are using more number of entries, or inside QoS you have ACL and those ACLs are using more number of MAC addresses, even if you have more number of routings, or you are getting more number of prefixes into your device, your TCAM will exhaust. So if your TCAM will exhaust, that means what will happen? We know in the switch world, and it's very common type of attack. So if suppose your switch TCAM space is 4K, that is 4096. If all the TCAM space will exhaust inside a switch, and this may happen due to layer 2 loop, then your switch will become hub. Means whenever packet will come to your switch, it will forward to all the direction, because it don't have any TCAM space inside the switch. So packet will come and it will go. It will come and go. Means your switch will behave like a hub. Now, what will happen in layer 3 switch? The same thing, but you will get some messages. Means some of your services like QoS service or ACL service or NetFlow service will stop working. Why? Because they will try to empty the MAC addresses as well. That is already full. Now in this case, they are not full due to loop. They are full due to they don't have that much space for all these services. So if you check your show platform, your hardware capacity, will come to know that for all these services, some MAC addresses are reserved. In layer 3 switches, some of the layer 3 switches we have SDM template. So those SDM templates have different templates like desktop or routing. There are 4 or 5 different templates with respect to SDM. Means what they are doing, that they are dividing the MAC address, because this is the fixed thing. Whatever MAC address you have in your hardware, that is fixed. You can't increase that MAC address, and that is fixed thing, and they are divided in IPv4, QoS, ACL, or NetFlow. So you have to wisely use all those services. Otherwise your MAC will full and your service will will not work properly. So here they will calculate the CAM entry, they will do the lookup for the CAM table, and then it will go to the egress pipe. So let me go to the egress pipeline. Now it is checking the ingress policing. Now it is here in the egress pipeline. In the egress pipeline, now they are checking the egress ACL and QoS. So how to correlate this? So whenever the packet enters, what they have done, they have checked the ingress and the egress ACL. When the packet is coming inside the pipe, at the moment it is moving to the egress, they are checking the egress ACL and QoS. So you can think that this is a step number 1 with respect to ingress and egress. Okay, now what will happen? Egress net flow, same things are happening now. Egress net flow, egress policing, all these things are in the egress direction. They are not in the ingress direction. You have to understand, this is suppose your interface, the packet is coming, that is ingress. Now after all the calculation, the packet is going outside, so the outside is egress. Now when the packet is going outside as well, there are policies that we are checking. So we can check the ACL, QoS, net flow, egress policing. But when a packet is leaving out, when it is going out, at that time we have less number of checks. And then it is going to the L2 engine. So L2 engine, what they are doing, the egress MAC lookup and the IGMP snooping. This is the life inside the forwarding engine. If you have any doubt on this, you can ask. I'll pause the recording for a moment. Hour limit. Okay, so just hold on for 1 day and go through with, maybe you will find all these things easy and maybe you are ready to go with the fabric module, but still take your time, go through all these slides, because amazingly we have covered 100 slides and all these slides are very informative और ये बहुत मजा आएगा आपको. आप हल्का सा नोट्स भी बनाते चलो साइड में, ठीक है. तो अच्छा लगेगा आपको। ये 175 स्लाइड्स आप समझ लोगे ना, तो आगे आपको कैटलिस्ट हो, नेक्सस हो, राउटर हो, कोई भी आर्किटेक्चर समझ में आएगा। दिस इज वेरी इंपॉर्टेंट। और अभी जब आप लोग केस पिक कर रहे होगे तो आपको पता चल रहा होगा कि कहानी कुछ और ही है। आपको हार्डवेयर लेवल पे ट्रबल शूटिंग करने पड़ रही होगी। So if you know all these features like NetFlow or module or packet forwarding, or if you know how to take captures, then it will be very very beneficial. और ऐसे ही केस आएंगे, चाहे वो इवन फायरवॉल में भी जब केसेस फंसते हैं तो वी हैव टू टेक कैप्चर्स। पैकेट कहाँ से आ रहा है, किधर जा रहा है, उसका कैप्चर लो, तो फिर पता चलता है कि क्या हो रहा है। स्विचेस में भी कहीं केस फंसेंगे तो हमको कैप्चर लेना पड़ेगा। ओके, सो कैप्चरिंग से याद आया, मैं आपको एक चीज़ बताता हूँ दैट इज़ वेरी इंपॉर्टेंट। सो मेरे को एक बंदे ने आज, इट्स वेरी इंपॉर्टेंट टू अंडरस्टैंड दिस। मेरे को एक बंदा है, उसने एक फाइल भेजा, बोला कि हाई सीपीयू है एंड आई टुक सम कैप्चर्स। ठीक है, इसको भी रिकॉर्ड कर देता हूँ सो इट विल बी हेल्पफुल फॉर अदर्स। I'm stopping the recording. If you have any doubt, you can ask. So this is recorded. When I upload on YouTube, please go through this portion as well. This 10-minute portion that I explain you. How you can filter, how you can't filter. You have some filters. If you want some filters, you can take those filters inside GNS and you can do this filtering thing. Okay, any doubt till this point? Okay. ठीक है, आप लोग को जो भी बेसिक क्वेश्चंस भी होंगे आप पूछते रहना, अपने डाउट क्लियर करते रहना।
ठीक है भाई, भाई वो
कौन सा? दो वॉइस एक साथ आ रहे हैं।
डायग्नोस्टिक कमांड लाइन।
ओके, डायग्नोस्टिक, ओके, ऑफलाइन में बताता हूँ। शशि आप चाहो तो निकल सकते हो।
कोई नहीं, मैं रहता हूँ।
ठीक, डायग्नोस्टिक कमांड सर्च कर सकते हो, इट्स ए वेरी बेसिक। सो अगर आप लिखोगे लाइन कार्ड 6500 डायग्नोस्टिक, हम लोग ये गोल्ड टेस्ट कवर करने वाले हैं आने वाले 2-3 क्लास में। विल कवर गोल्ड टेस्ट, सो उसमें थोड़ा सा और भी क्लियर होगा। लैपटॉप बहुत स्लो हो गया, एक बार रिबूट करना पड़ेगा।
इंजीनियर भेजे
क्रिटिकल इशू है।
देख रहे हो कितना स्लो हो गया लैपटॉप, इतना स्लो लैपटॉप मैंने कभी यूज नहीं किया। ओके, देखो ये है ना जेनरिक ऑनलाइन डायग्नोस्टिक ऑन कैटलिस्ट 6500। हालांकि ये सब मैं कवर करूंगा आने वाले क्लास में। गोल्ड टेस्ट के बारे में बता रहा है कि कौन कौन सा। तो जब करते हैं ना, कोई एक पर्टिकुलर लाइन कार्ड है जिसको तुमको चेक करना है, तो लिखते हैं डायग्नोस्टिक बूटअप लेवल और कंप्लीट। बाय डिफॉल्ट उसमें होता है मिनिमम। ठीक है, तो डायग्नोस्टिक मॉनिटर इंटरवल मॉड्यूल 5 टेस्ट, ये सेट कर रहा है उसको। तो ये लेबल्स होते हैं उसके अंदर, आप कंप्लीट कर दोगे ना तो कंप्लीट वो सारे टेस्ट करेगा उसके अंदर। अभी देखो ये मैंने पढ़ाया नहीं ना सूप 720 और सूप 2T, लेकिन अब देखोगे तो आपको लगा अरे लेयर 2 इंजन, लेयर 3 इंजन, पोर्ट एसिक, ईओबीसी, है ना, ये सब चीजें अब आपको लगे, वो फैब्रिक आपको लगेगी यार ये तो कर सकते हैं। देखो शो डायग्नोस्टिक कंटेंट मॉड्यूल 5, तो वो सारे टेस्ट के रिजल्ट नीचे दिखा रहा है और इसमें और डिटेल से ही बताया है कि क्या मीनिंग है उनका। ठीक है, तो एक तो ये लिंक है, और भी लिंक होंगे यार, काफ़ी कुछ मिल जाते हैं, ये सब काफ़ी बेसिक चीज़ें हो गई हैं आजकल, तो यू विल गेट इट। मैं देख रहा हूँ कि एग्जैक्ट कमांड मिल जाए। हाँ सेम ही लिंक है लगता है ये। डायग्नोस्टिक, ये डायग्नोस्टिक लेवल कंप्लीट आपको करना पड़ेगा। और आप जब रिबूट करते हो ना उस मॉड्यूल को, उसके पहले वो कर दो कंप्लीट, तो रिबूट करके वो सारे चेक्स करेगा उस पर। शो डायग्नोस्टिक मॉड 1, तो बट आपको ग्लोबल कॉन्फ़िगरेशन मोड पे जाके पहले उसको कंप्लीट करना है, तभी आप मतलब बनेगा इसको देखने का। ठीक है, कर लो, इट्स वेरी इजी थिंग, आप इसको देख लो।
ओके
ठीक है, आपको लिंक में
ओके
पिन कर दूं कि सर्च कर लोगे आप?
हाँ कर लूंगा ये तो सर।
कर लो, ठीक है कर लो। और कोई अगर इश्यू हो तो मेरे को कॉल करो।
ओके भाई सर।
ठीक है, चले फिर,
ओके
चलो फिर,
हाँ
चलो
ओके
बाय
गुड
बाय, गुड
नाइट।
नाइट, चलो बाय। So this is the
Yes, yes, you can.
8th session on Nexus part 8. This is 8th of the fabric of the Nexus architecture. Today I'm going to discuss about the fabric architecture, but before that, let me explain this thing because this is one of the important slide of Nexus. Before starting this one, I'll tell you what are the important components inside Nexus. So inside Nexus switch, if you see Nexus switch or any catalyst modular platform, what you will find is, suppose this is your chassis. So in this chassis, you have line card and you have SOUP. Suppose this is your SOUP, this is your line cards, like that. Now inside this supervisor engine, actually we have discussed about M series line card, but you can take example of this supervisor engine as well. So inside this supervisor engine, we have different type of components. So what are the components you have? You have different type of ASICs. So you have ASICs related to interface. You have some central ASICs. You have fabric ASICs, like that. And one of the most important thing inside this supervisor engine is URL. That is the layer 2 and layer 3 forwarding engine. So I'm going to explain that whenever packet is coming inside URL, how the URL processes that packet or that frame. So if frame will come, it will process with respect to L2 engine. If packet will come, it will do all the lookups with respect to L3 engine. That is Lamira and some other engine. So let me show you this here in this diagram first. That is Eureka and Lamira, layer 2 and layer 3 engine. Okay, so you can see here in your screen that I have I am inside the forwarding engine. That forwarding engine is nothing but the URL 8. So whenever a packet will come, that is the ingress to a layer 2 engine, then what will happen? What will be the next step? And what are the lookups we have? You can see here we have two pipes. One pipe is for ingress, other pipeline is for egress. So there are certain lookups that will happen when a packet will come inside, that is the ingress direction, and then the circulation, that is the ingress and the egress pipelines. So what are the lookups will happen here? You can see that inside L2 engine, the card will look up for the features like IGMP snooping, redirection, and different type of MAC lookups they will do. Yeah, obviously we know that at the rate of layer 2, we are doing the MAC lookup. So you may have different type of features like link sec or Cisco trust sec or MACsec. You may have other features like ARP snooping or other features, layer 2 features. Okay, after that the packet will go for L3 lookup. At the L3 side, what are the things it will check? Now remember, this is the ingress packet, means the packet is going towards L3. So first of all, it will check for the reverse path forwarding, that is the RPF check, and this is in the unicast direction. So we have this reverse path forwarding both for unicast and multicast. We'll check that. Then the next lookup it will do, it will check the ingress ACL and QoS, that is the class of service classifications. Then it will check the net flow. So already I told you in the last previous session that what are the lookups that generally these engines are doing, and they are not checking. It's very important to understand. They are not checking the entire packet and entire payload and header. They are only checking the header. So once a packet is coming towards the interface, interfaces have a specific ASIC, and we know that R2D2 and R2D2 is again mapped with two different ASIC, that is, I don't know, Octopus or something. I'm not remembering that, but still they have two different ASICs, like one is the replication engine and other one is the central ASIC for all the interface ASICs. So what will happen after the replication engine or after the central ASIC, they are sending only the header information to the FEs, to the forwarding engine. Now it's very important to understand that at the forwarding engine they will check for net flow, they will check for IPv4 and IPv6, means they will do all these routing lookups. They will check for ACL and they will check for QoS. All these features are associated with MAC address. Okay, in case suppose if you don't have MAC address, means in some other technology like frame relay or ATM or SDLC or PPP or SONET, in these technology these things are not using the MAC addresses, but they have some L2 lookups or they have L2 things. Like in frame relay, you may know that they have DLCIs. In ATM, they have something VCI, means virtual circuits, virtual private circuits, like that. In SONET or in other Ethernet technology, they have other than encapsulation with respect to L2. So they will do the L2 lookup. Okay, and then it will go to this engine here. ACL and QoS is happening. Then again it will process this pipeline. It will reach till here. So we'll see what is the next lookup. So you can see here they are checking the FibCam, TCAM. What is the utilization of TCAM and what is the adjacency table lookup for L2 to L3. They will do the ECMP hashing for multicast RPF. So we have two type of RPF here. One is unicast reverse path forwarding. One is the multicast reverse path forwarding. After that, the packet will move to the next level. So the next level is the ingress policing. Once the packet will circulate to this L3 engine, once they will do all type of lookups with respect to QoS, with respect to ACL, with respect to net flow. Now net flow is very different feature than all these things, and with respect to L3 to L2 adjacency table, that is basically used in the routing whenever the routers or switches, they are taking the routing decision. So the L3 IP addresses, whatever adjacent MAC addresses for those L3 IP addresses, they are again writing down to the hardware level. So this is this adjacency table. They are making their own adjacency table. In other terms, it is known as CEF, Cisco Express Forwarding. Okay, so this L3 information, whatever the next available MAC address will be there, either that MAC address is associated with the interface or maybe with VLAN, probably they will write it down to the layer 2 engine. Okay, so once the ingress lookup will happen, the packet will move to the egress pipeline. So what are the things in the egress pipeline? We can check that. Again, they are checking for the egress net flow collection, then the egress policing. Once all these lookups will happen, the packet will reach to the layer 2 egress. Now, important thing here to understand that when a packet is coming inside, the first major lookup is ACL and QoS in the ingress direction. If I mark this as a 1, you can see in the egress direction, the first lookup is ACL and QoS. The second one is net flow. Here in the egress as well, net flow. Third one is the egress policing. Here we have the ingress policing. So this is the layer 3 lookup. Then layer 2 lookups are easy. So while the packet is entering, while the frame is entering to the layer 2 engine, obviously the layer 2 header, at that time these lookups are happen. And at the egressing, they are checking the IGMP snooping table and the MAC lookups. So this is the lookup. Please go through it 2-3 times, then you will understand what are the lookups you have. Now for all the platforms, at least for the switches, we have this lookup. Maybe for ASA firewall, the order of lookup is different, and for other security devices, the order of lookups may be different. That you can search, you can Google it for that. Okay, so this is the lookup. What I'm going to hit next is the fabric architecture. So till this point, if you have any doubt, you can ask. I'll pause the recording for 2 minutes. So the next topic is to how the fab module works inside the Nexus and what is the importance of these fab modules. You can see here in this particular Nexus 7K series, here you can see that the 7010 is providing 46 kbps of throughput per IO module or per line card. Now how they are providing this 46 gig of speed plus the overall speed is 80 gig per slot with 10 gig module. How they are providing such type of throughput, for that I have very good slides, and you will understand that what is the importance of fab modules as well in this particular presentation. Let me go to the important slide. I'll come back on these slides. So you can see here the mechanical topology or diagram of Nexus 7010. And this particular Nexus switch, we have line card 1, 2, 3 up to 10. Inside that we have 2 SOUP engines. Now all these line cards and all these SOUP engines, they are mapped with the fab module. And you can see per line card we have 2 trays. And one trace has a bandwidth of 23 gigabit in case of 7010. So 23 into 2, that is 46. Now 46 into 10, ideally it will come 460, but for the supervisor engine you have exception. For supervisor engine we have only one trace, so that means you have to subtract 46 into this and you will get the total throughput. Now you can ask that why for supervisor engine we have one trace. Because generally we don't want to engage supervisor engines for data forwarding. So we want that supervisor engines, they will do only the control plane things. So they will take the decision. Those decision they will again program to the line card, and then the line card, it's up to line card that how they are forwarding the frames or packets. So for the supervisor engine, the overall for 2 supervisor engine it's 46, and that is the design for the fab module. So behind the scene, if you see the topology, you'll find that you have, say, up to 5 fab modules inside a chassis. I'll show you the diagram, but internally they are mapped. So this is the position of the fab module. If you see, this is some 7090, sorry, 7009 Nexus switch. In 7009 switch, the supervisor engine placement is on the top. So on the top, we have 2 soup engines. Now you can see here we have 5 fab modules. This is not like these fab modules are inserted in between of this particular uh, architecture, but actually they are mapped. So I'll show you in the next slide that how they are mapped. But actually all these fab modules are mapped. So a single line card is having a throughput of 46 gig, and here you can see the other side view that they are mapped. So 2 traces of a particular line card is mapped with a fab module.
So every LAN card mapped with one fabric card.
That I'll show you that. That's really good question here. So you can see here in this particular diagram that suppose I have various line cards. So all the line cards, they are mapped with all the fab modules. So it's not like that. Suppose if in your Nexus switch you have only one fab module. So you have up to 5 modules. That is the maximum. But suppose if you have only one fab module, then what will happen? So you can see all the line cards are mapped with all the fab modules. Okay, for the sake of redundancy, at a time only one, actually only 2 fab modules will be active at a time, because one trace is up to 23 gig. So at a time they are getting a backplane speed of 46 gig.
Okay.
So they are mapped with all the lines.
What the exact role of fabric module?
Yeah, that is again a good question. So I'll tell you what is the importance of this fabric module. So this is your chassis, and suppose for the sake of simplicity, I have one soup engine and I have line card 1, line card 2 and line card 3. Now these line cards are something like 48 gigi. So 48 ports are there, and all the ports have 1 gigi of throughput. So when the packet will come, suppose it is coming here and it is leaving from here. So this is my input and this is my output. So what will happen when the packet will come to this particular line card here, my PC, and this PC wants a throughput of suppose 1 gigi. I am using some application, and that due to that application I am generating 1 gigi of speed for this line card and for this line card for source to destination. This is my destination. So what will happen? How the frame will come here and move there? It's very easy. What will happen? Your FEs. So
field engineer.
It's not field engineer. We have just discussed. We have
just fast Ethernet.
It's not fast Ethernet. These are the forwarding engine. So we have 2 engines.
Forwarding.
Yeah, we have 2 engines here, and these 2 engines you can see here. Actually, field engineers, you can tell this, no problem. So these in field engineers, we have layer 2 field engineers and layer 3 field engineers. They are doing the actual job. So when a packet will come from one line card, it will go to the other, and once the decision will happen, it will go out. So you are requiring 1 gigi speed here, 1 gigi speed here. Okay.
Okay.
And think about that, you have 10 applications. So overall requirement is 10 gigi. Okay.
10 gigi.
For input and 10 gigi for output. Now think that who will provide you 10 gigi?
That
is the
forward
backplane.
engine.
That is the backplane of your switch. So forwarding engine, what it will do, it will just take the decision. He is the decision maker. He is not someone who is providing you the throughput. So for forwarding engine, he will take the decision, he will check the ACL, he will check the QoS, he will check other parameters, and once, because whenever we are sending anything to the forwarding engine, that is only the header. We are not sending the payload to the field engineers. We are sending only the headers, either it is layer 2 or layer 3 field engineers. So they are taking the decision with their algorithms or whatever they have inside their decision making. So the backplane is providing you the throughput, and this backplane is very important in all the switches. So either it is 6K or 7600 series router, or it is Nexus modular switch. The fab modules are actually responsible to provide you the throughput, and I think we have already discussed this in previous session, that how the packets are reaching to the fab module. For you also, we'll discuss that in the upcoming classes because you missed something. Actually, what happens, this is a 32 port F1 card. You can see here in this F1 card. So whenever, let me scroll down a little bit. Yeah. So interfaces, they are mapped with the ASICs. So they are mapped with the switch on chip, and they are mapped with the fabric ASIC. So to take the decision, the packet will go here. Actually, this is not the slide. Let me open the actual slide where we have packet walk. It is somewhere here. Yeah. This is again one of the most important slide. Let me enlarge it. So packet is coming. It is going to replication engine or the other ASIC. That is again going to the L2 or L3. That is the Eureka and Lamira. Now these things, what they are doing, they are returning the packet, but they are returning the packet to the forwarding engine. Sorry, to the fabric ASIC. That is your backplane. So if I click here, you can see the packet is going. The important one is the 10 and 11. So 10 is okay. Forget 10. Check 11. Credit grant for fabric. Credit grant for fabric access. So packet from here, this is the source, and this side is the destination. But from source to destination, the packet is traveling from the fabric, say from the ASICs to the field engineers to the fabric ASICs. Then it is going to the main fabric module. You can see here you have fabric module 1, 2, 3, 4, 5. This fabric modules, they have some credit. So this is something like buffer to buffer credit. So they are taking the tokens. Means you want to send 5 packets. So they are taking the decision, okay, 5 packet is coming and I am sending the 5 packets. So whatever throughput is there, that 5 or maybe 5 million packets are coming, and I am taking the, I am granting the 5 million packets in my ingress, and I am sending the 5 million packet to the egress. That is done via these fabric modules. Okay, so this is the overall architecture of, you can say, all the switch. So you have something here at the rate of layer 2 hardware. You have something here at the rate of layer 2, layer 3 decision making, something that is the forwarding engine, and here you have the throughput. This who will provide you 480 gig of speed. That is the fab modules. Okay, so this is the heart of any switch backplane. So maybe sometimes whenever you are getting cases related to that, my switch is not stable, or it has lots of
packet loss.
Packet loss, it had temperature issue.
Sometimes we receive packet loss.
Yeah, sometimes reload will fix the issue. Sometimes if you change the supervisor engine, it will fix the issue. But sometimes that is quite rare, but you have to change the backplane. Okay, that means you have to change the chassis in case of switch. In case of Nexus, you have to check out the fab modules. Okay, so I am somewhere here on the fabric module. So I think it is a bit clear that what is the use of fabric module, and here there are some calculation related to that. One last thing I want to discuss in the chassis, that is the
Yeah.
virtual. Yeah. You have any question?
No, no.
Okay. So one important thing that I want to discuss about this particular chassis, and then we'll move to feature. So till this point we are discussing about the Nexus chassis, Nexus architecture. The last thing that I want to discuss is the virtual output queue. Okay, so from this particular diagram, you can see that suppose I have two types of traffic. One is this orange, one is this blue. Now this blue traffic, you can see that they are in between the orange, and these are suppose voice traffic. Now for voice traffic, their latency is less than 150 millisecond. So if they have to stay in a queue for more than 150 millisecond, automatically they will destroy themselves. Okay, so this problem you can solve with the QoS policy. That in the QoS policy, whatever pipeline you have, in that particular pipeline you can reserve some bandwidth for high latency, or you can say the low latency traffic or important traffics. So here you can reserve 10%. But in Yeah, obviously you can apply QoS and you can do that. But in case of this particular architecture, we have this concept of virtual output queue. So what this virtual output queue will do, and this is very different than the QoS, normal QoS. Please do not relate this VOQ with the actual QoS. So what this virtual output queue will do, that it will create one separate lane for this blue traffic. Okay, so blue traffic, they have different destination, and this particular have orange one has the different destination. So the solution is via virtual output queue. So when we have seen the architecture of Nexus, we have seen that we have virtual output queues as well. So before coming to this particular slide, we can go back. If I'm going back, if you're not using your audio, you can mute yourself, because I'm recording this session. And whenever you want to ask anything, you can just unmute and ask. Okay, so you can see here in this M2 line card architecture, this is just for an example. We have some VOQs as well. At that time I have a script. I told you that in upcoming class I'll tell you what these VOQs are. Now conceptually or theoretically, it's very easy to understand the architecture. And again I'm repeating this. What happened, even in all the platforms, the interfaces, they have some ASICs. So suppose this is my interface, 12 into 10 gig interface. They are mapped with ASIC. This is a feature MAXEC, but they are mapped with some ASICs. These ASICs, you can see here, they are mapped with the replication engine, because you may have multicast traffic as well. And they are mapped with the VOQs as well. Means when the traffic will come here, it will not get bandwidth in the normal queue, it will go to the virtual queue. Okay, so this virtual queue concept is nothing but to provide you virtual memory or virtual buffer in the normal ingress packet or in the normal scenario. If I go to VOQ, you can see the definition of VOQ. So how this virtual queue work, and even here also, if I scroll it little bit, you can read through it. So one solution for hall blocking to create second queue. Yeah, we have one other queue for other traffics. And this solution is engineered to support Cisco Unified IO line card. It can provide no drop service across the fabric for the future FCoE traffic. So what happened in this particular fabric channel over Ethernet, that there are some traffic. Actually, there are two types of traffic. One traffic is Ethernet traffic, and one traffic is fabric channel or native fabric channel traffic. That is something related to storage. So in this particular unified solution means what happened, suppose if you have 5596 Nexus, those are, suppose this is my 5596, those ports are actually unified port, that is UP. So those unified port, either you can turn or they can act as a Ethernet, or they can act as a FC, fabric channel. Now the issue with the fabric channel that FC traffic should be lossless. The Ethernet channel is not, or Ethernet traffic is not lossless. Why they are not lossless? Because they are using TCP. So for transmission, what Ethernet is doing, they are relying on the TCP protocol, and in TCP we know that if some drops are there, they will retransmit. So first they will do the three-way handshaking. If there is any problem in the network or congestion or any packet drop, they will retransmit the packet, but you have packet drops. In FC, you can't expect this. So that's why they come with this concept of VOQ, that is again used in FCoE, that you have some reservation inside a main bandwidth or inside a main pool of bandwidth, where you have one main lane and you have parallel lane. So your packet will not drop due to any latency. Okay, so this is the solution for unified Cisco unified architecture, that we have one parallel queue in case of congestion. If there is no congestion, there is no QoS. QoS is only applicable when you have congestion. Okay, so let me go to the next slide, and again this is the VOQ slide. So here also the same target will achieve. So when the packet is coming inside, I think I have animation for this. Let me show you that. Okay, so you can see here three-stage architecture, crossbar architecture that we have in the Nexus. So let me click. We have this 5 fab modules, fab A, B, C, D. This is my central ASIC. Again, if you see the previous topologies or previous architecture diagram, you'll come to know that packet is ingressing. The packet is coming from this interface. Now they have crossed all the local ASICs. Now they are mapped with the Santa Cruz, that is the central fabric ASIC. These fabric ASICs are mapped with, internally they are mapped with the fab modules. That's correct. And then this is my, oh sorry for that. So this is my incoming traffic and this is my outgoing traffic. So that's why these are the three-stage crossbar fabric. And if you understand the initial slides, then you'll find it easy. And let me go to the same thing, you can just have a look. And this is the calculation how the buffer to buffer credit happens in this model. You can just go through all these slides. You'll find it easy. This is again the same mapping from the local ASIC to the Santa Cruz, that is the central fabric ASIC. Yeah, these are the port mappings. Okay, so let me just pause the recording for a moment, and if you have any doubt, so you can see here on your screen that how the fab modules are mapped with the line card. So in this case, you can see these line cards are mapped, even the supervisor engine are mapped with the fab 1, 2, 3, 4, 5, 6, 5, not 6. So up to we have 5 fab modules, and overall throughput is 330 gigi. And again, these are the mappings. So this is the overall architecture that we have discussed so far. Now in this particular presentation, the other things that I am going to discuss is what are the features that we are running on the top of Nexus switch, and that will be like brief introduction, because for all the features we have separate class. So what is the use of VDC and how we are creating VDC, for that I have separate class. For VPC, I have separate class. For fabric path, I have separate class. So for all the features, I have separate classes. Before starting that particular thing, one important thing to discuss here is that how these particular chassis or these mixture of VDCs, how they work when we have mixed line cards. So we have seen in our previous sessions that we have basically two type of line card. Either they are F series line card or they are M series line card. So you may have F1 or F2. Forget about F2E and F3 for the moment. You may have suppose F1, F2, or you may have M1 or M2 line cards. So initially when they launched, means 5-6 year ago when they have launched these line cards, the F series line cards are directly proportional to L2 and M series line card was directly proportional to L3 services. So whatever L2 services you have like STP or ARP or snooping, IGMP snooping, all these services are mapped directly with the L2, and routing related or maybe PIM related or other L3 services are mapped with the M cards. For those type of mix environment, suppose if you want to route, suppose if you want to send traffic between two VLANs, so you know that in case of VLAN, the routers in the old ages, routers, they are used to do a router on a stick. Means you have two switch. Suppose this is in VLAN 10, this is in VLAN 20, and then you are, suppose they are connected like this. Even suppose in the single switch, suppose they are, this is one switch. In single switch, I have two VLAN, VLAN 10 and VLAN 20. So if you have PC in VLAN 10, they want to communicate with the PC in VLAN 20. The concept for router on a stick means your packet will go here, your tagged frame with 10 will go to the interface, that is a sub interface, something F0.1 and F0.2, and again they will change the gateways. So once they change the gateway, the 10 will get the tagging of 20, and like that they are doing their communication. So that was the router on a stick concept when we have VLAN 10 and VLAN 20. Now in case of this type of design where the inside Nexus switch you have VLAN 10 and VLAN 20, and they want to do the L3 things, L3 forwarding, means F1 card they don't have capability of do L3, so they will proxy to M card, and the M card has the default gateway for other VLAN. In this way they will communicate. So if I make this very simple, the traffic will go to M card for L3 decision and then it will come back. If you are going from F1 to M1, it was very easy. From F1 you can go to M1. This is the worst case. From F1 you are going to M1 and then again you are going to other M1 line card. But this is the classical example of proxy. Proxy in case of M cards are doing proxy for F card. Okay, so this is example of mixture of M card and F card. Now these things are not applicable in the modern data center design, because in the modern data center design we are using F3 line cards, and F3 line cards are capable of doing the L3 things. So not only they are doing the L2, means they are capable of doing the L2 stuffs, but they are capable of doing the L3 the decision as well, like that. So please have a look on this slide as well. Let me go to the next slide, and there are some limitation as well. I will come to this particular VDC. I think I'm going to take 2 to 3 classes on this VDC. So please do not worry on this virtual device context. I'm going to come on this. I have separate PPT for this, and we'll perform labs on this. There are something related to VDC. I'll come on these VDCs. Now the feature compatibility and the interactions. In this particular PPT, this is one of the important PPT. Now let us revise the proxy forwarding inside this. So what will happen, And at least we know that now these interfaces, they are mapped with the ASIC or the replication engine. They are again mapped with the virtual output queue and the forwarding engine. Now they have the central ASIC, that is the Santa Cruz, and from central ASIC, so this is M card, and how the traffic from M card is going to the F card. So suppose in this particular case, what I want to do, I want to send traffic from VLAN 10 to VLAN 20. So what will happen? The traffic will come first to M because F cards, specifically F1 cards. So F1 cards are not able to take L3 decisions. So what will happen? The packet will come to M for proxy routing, and then from here it will go back. So I have wonderful animation for that. If I click here, you'll come to know that how the packet forwarding is happening here. So you can see here the packet is coming, that is going to all the M cards, replication engine. It is taking the decision, is going back, and then it is going towards the other F card. Okay, so again, this is the important thing